So lightweight cryptography is a study of tailor-made solutions for such IoT devices like this RFID tags, sensor nodes, smart cards, etc. Okay, so that is the kind of thing we are going to look at in the next 20 minutes or so. So, what are the target devices and how do we benchmark meaning the crypto implementation, for example? So, like I said, primary target devices are embedded systems, RFID devices, sensor networks, sensor nodes, etc. So, if you look at microcontrollers, I think meaning our hardware team are better suited to comment on this, but I just want to make a point that microcontrollers typically support a small set of instructions. So if you are implementing a very complex crypto algorithm there, so it would involve usage of many cycles, so which is undesirable. So there are some examples of RFID tags which do not have any battery source. So they do not have any power supply. They just meaning draw power from some of the ambient sources. So in which case we need to have less gate equivalence and less power consumption crypto implementation. So the crypto algorithm itself should be very efficient, and the implementation should also be meaning carry out that property. So suppose you are in a scenario where sensor network, there are various sensors, and they are collecting data and sending it to a server for aggregation. So we know that like what I was saying, the sensors are lightweight, so they will run lightweight crypto. But suppose there is a server which is aggregating this data, so that is not a meaning resource constrained device. Whatever crypto the sensor nodes are using, it should be understandable by that server, the aggregating device, so-called server or this desktop or laptop, etc. So, so that makes the problem even more challenging. So, you may design something which is secure enough for a sensor, so will it be secure enough for a server? So, you can see that there is a heterogeneity in the devices which are involved in this network. Okay, so in a nutshell, so you have to think about the environment and application. Traditional is applicable or not. So you can have for example, sensor, meaning IoT network in which the devices involved are somewhat having a lot of resources, in which case you can continue to use your traditional block ciphers like KES 128 to 56, etc. But in some applications, your meaning devices may have very small amount of resources. So in which case you cannot use these meaning resource intensive crypto algorithms. Okay. You have to also, like I said, there is this heterogeneity in the devices involved. So you have to look at what all devices are involved in this kind of a particular application. Okay. So I think again this is meaning our hardware team can talk better rather than me. So you can measure the performance in terms of power and energy consumption, latency, throughput, etc. So the resources required are quantified in terms of gate area, gate equivalence, logic blocks, etc. So like I said, the RFID tags, so they may not have any power source. They may harvest power from the surroundings. So you need to have a crypto algorithm which should draw very less power. So we know that latency, for example, is defined as the time between, meaning I've just given an example where you are requesting for authentication, you are getting back the result. So that is the latency of this crypto algorithm. So that is what we are going to meaning look at. And you have to look at also the throughput, so the rate at which the new outputs are produced. So meaning high throughput is not the design. For example, the sensor network or the RFID IoT system, it may have a certain kind of application in mind. So whatever crypto you are putting in this kind of a scenario is going to sit on top of that application. So it should not kind of consume more resources. So ideally, high throughput is not a design goal. So moderate throughput is sufficient in most of the scenarios. Okay, so like I said, our hardware team are better equipped to talk about this FPGA ASIC, meaning the the so-called area occupied by this crypto implementation in terms of this logic blocks, gate equivalence, etc. So these are the target devices we are talking about, and these are the benchmarking metrics we are going to talk about. Okay. So when you talk about lightweight, it is not synonymous to weak. So there is to be a balance between security, performance, and resources. And the main point here I want to point out is that when you design a crypto primitive, a crypto algorithm, so you may limit the power of an attacker. So for example, when you look at this block cipher, so when you talk about the security of a block cipher in a traditional sense, not the side channel attack. So the classical attack on a block cipher, you may assume that you have with you say 2 to the power 128 plain text cipher text pairs, all of them encrypted using the same key. So such kind of assumptions may not hold for your lightweight crypto primitives. Like when you talk about say linear differential attacks, so you assume that you have the adversary, that is the adversary has so many plain text cipher text pairs, all of them encrypted using the same key. So that kind of assumption you cannot make for your lightweight crypto primitives. This is not intended for wide range of applications. Okay, so there is a trade-off. Like I said, that the heterogeneity is there, but meaning you have to say that your server side is protected, and it may not see such frequent attacks on it. Okay, so that is the kind of assumptions we have to make. And like I said, these are not intended for wide range of applications, right? Yeah. So I just want to give an overview of what ciphers are there, etc., etc. And I will not be covering design of any of them, meaning going into what is there inside the various things I'm going to talk about. I'm just going to kind of talk only about the symmetric key side. I'm not going to touch upon the public key side. I think there is one talk on the internet key exchange, I think. So this is mainly about only symmetric key ciphers. Okay. So let us look at block cipher. So all of us know block cipher. So you would have seen, for example, this DES and DES. Keeping that in mind, so we know that we have this SPN substitution permutation network or the facial structure. So meaning those design ideas again get meaning you can use those design ideas even in this lightweight side. But what you would have is that you will have smaller block sizes. So you will have 64 or 80-bit block ciphers rather than 128 bits. I'm talking about the size of the block here. So, like I said, some people may say that meaning 2 to the power 64 is not a big number. So you have to say that the adversary does not have a lot of data all encrypted under the same key. Like you say that you will restrict by making the assumption that the attacker cannot have so many ciphertext plain text ciphertext pairs, all of them derived using the same key. So that's the kind of assumption you make. Okay. Then you talk about the key size. So I personally like present very much, and so there is a cipher called present. So it has a 80-bit variant. So meaning the present block cipher has a block size of 64, and it has one variant which is using a 80-bit key. Okay. And next meaning design criteria which we need to use when designing this lightweight block cipher is that it should have simpler rounds. So we know that AES has so many mixed columns, shift rows, mixed columns, etc., right? And it is based on an 8x8 S box. So when we talk about lightweight block ciphers, for example, present uses a 4x4 S box. Okay, so rather than using 8x8 S boxes, you just use a nice 4x4 S box. And so there is also a linear layer. So I'm just talking about the SPN kind of a structure. So in which case, rather than going into shift rows, mixed columns, etc., you do a simple bit permutation. So S box since present uses a simple bitwise permutation. So there will be 64 bit state. So each of these bits, bits in this state will go to certain other bits. Okay. So there is a simple bit permutation, and meaning there is a lot of study on using MDS-like matrices for meaning making this linear kind of this layer for this block cipher. So there is this substitution and permutation frame. So for substitution, use some simple S box like 4x4, And when you talk about this linear layer, namely this permutation layer, use simple operations like this bit permutation, or use a MDS matrix to permute this state. Okay. But on the negative, what we have is that if you have a simple round function, you may need to have more rounds. So, for example, present has 31 rounds, right? Yeah, I think present has 31 rounds. And meaning AES has a key schedule, right? So complex key schedules will increase memory latency and power consumption. So it's better to have a very simple key schedule or no key schedule at all. So, like for example, Prince does not have any key schedule at all. And say, for example, you are just talking about, say, using this IoT device as an encryption device, then you may just implement this block cipher in the encryption in a particular encryption mode alone. So you need not have a suite of algorithms with this block cipher and the device being able to do all these kinds of operations. So you can just restrict to encryption. Say, for example, that is what is required for your IoT device, then you just do only encryption and meaning a particular suitable mode of operation for that operation. Okay. So these are the criteria which we need to look at when we are implementing or designing any lightweight block cipher. So there are many examples, like I said in the beginning. So I'm not going to talk about any particular design here. Like there are many of these examples. Present, Prince, LED, Simon, or Spec, and then TEA, meaning tiny encryption algorithm, and there is an extension of that. So XTEA, all these are examples of lightweight block ciphers, right? And then there is this. Let us look at what is happening in the lightweight stream cipher and MAC areas. So if you look at this lightweight stream cipher domain, so there was this E-stream competition. So in which 3 stream ciphers were shortlisted, namely Grain, Trivium, and Wiki. So these are the 3 E-stream finalists. So these are being kind of approved for usage in this IoT kind of scenario, right? And then we all know what is MAC, right? So MAC stands for message authentication codes. So you can use, for example, hash function with a key to put a tag on your message. So in the symmetric key setting, so the sender and the receiver have the same key. So the receiver also takes this message, this tag under the copy of the key and verifies whether this message and the tag match or not. So this MAC is used, as we all know, for authentication integrity checks. So in a symmetric key scenario, you can achieve it either using your hash function or using your block cipher. So you can use your block cipher, then keep running the block cipher, take the output from the from the last block that use kind of a tag on your message. So you can use a particular mode of operation for your block cipher. Using the same key, it can be verified at the other end also. So you can use MACs for doing integrity and authenticity checks in a IoT kind of a scenario. And examples are JASKey, TULP, and LightMAC. Okay. Again, I'm not going to talk about any of this designs in this talk. Okay. And then hash. So like we need to also talk about hash functions, right? So whatever data is being sent by this IoT nodes. So how does the server, for example, verify that the data is correct or not? So I'm not talking about a scenario where today morning we're seeing that, say the IoT, so the sensor node is just measuring temperature. So I'm not talking about that case. So you can have a scenario where the sensor nodes are collecting a lot of data and the data integrity needs to be checked at the server end. So we need to have some kind of a hash function where the data integrity is checked at the other end, right? So there are various kinds of hash functions which we talk about: SHA-1, SHA-2, SHA-3. So there is this SHA-3 which has lots of functionalities these days, and this is a NIST finalist, right? So which is kind of suitable in a a server or a block, a desktop kind of scenario, but that may not be good enough for a IoT kind of scenario because it will drain a lot of power. Okay, so what is being recommended here is that we need to have smaller internal state or output size. So we talk about the digest of the hash function, right? So I'm just saying that you should have a small digest size, and the internal state, like this hash function, will move from a state to state, right? So the internal state should be small, and the output size should be small. And normally, the rule of thumb is that we can compromise on collision resistance, right? So if you talk about the hash function, we need that it is to be pre-image resistant, second pre-image resistant, and then collision resistant, and so on, right? So in the IoT scenario, people generally talk about a scenario where the collision resistance is no longer needed. Like you say that let us compromise on that, and let us go in for a smaller internal state or a output size kind of a hash function. Okay. So this is one of the criteria for winning. This is one of the relaxation we make when the lightweight hash function is being designed. Okay. And we know that meaning when we talk about this big hash function, we say that it is a function from 0, 1 star to 0, 1 to the power L, where L is the size of the digest, right? So you can allow messages of arbitrary length, but your computer has a finite memory only. So you say that your hash function should be able to process a message, say, of length to the power 64, for example. So this is a condition which many of these competitions put. But in a IoT kind of a scenario, we need not have we will never have or we may not have any message which is of to the power, which is of 64-bit length. So your messages can be say 256 bits, for example. So you say that meaning you are not allowing arbitrary length messages. So whenever you want to search for say pre-image, meaning one of the pre-images, so you can just look at meaning from the adversarial point of view. The message is say only 256 bits. So that kind of puts a condition that you cannot have arbitrary, meaning the adversary cannot find meanings, can search for an arbitrary length pre-image, right? So that is putting a restriction on the adversary also. So some examples for these lightweight hash functions are photon, quark, spongent, etc. Okay. So I think today morning there was one talk on this standardization. So I just want to point out a couple of them. So one is this, there was this lightweight cryptography. There is one information security lab at NIST, and another is this which is looking at this meaning lightweight cryptography with applications to IoT security also. And they did something. I'll just talk about it in a couple of slides later. And another effort is by this ISO. So I think there was a slide today in the previous talk where there was a list of all the ISO standards which was listed by the speaker. Okay, I'll just talk about three of them in the next slides. So there is this. I think this was mentioned in the previous talk. So there is an ISO IEC 29192. So this has many parts. So this is talking about the general lightweight cryptography for applications in IoT security. So the first part I think is talking about this information, general information on security and classification. Like they are talking about what is the devices involved, what is the notion of security you are looking at, etc., etc. The next part is talking about block ciphers. There is one part on stream ciphers, asymmetric techniques, hash functions, MACs, broadcast authentication, and authenticated encryption. So there are 8 parts, I think. So this is what I could find out. And you can see that this is a mixture of both symmetric as well as asymmetric things which is being covered here. So in the asymmetric techniques, they're talking about the key agreement, signatures, etc. And there is this notion of broadcast authentication also. And the last one is this notion of authenticated encryption. I'll just talk about that in the last slide. And there is this ISO IEC 29161. So this is talking about automatic identification and capture and data capture techniques. So this is going to talk about what kind of security services are needed for this RFID air interactive services. So they have made a list of finalists. So this is the suite which this ISO has standardized. So one is this AES 128, then present with 80-bit key variant, and then elliptic curve cryptography based Diffie-Hellman ECC DH, and there are certain other members in this suite also. Okay, so the other one is by Cryptrek. So this is a Japanese set of standards. So they also did some study and kind of standardize certain of the crypto algorithms for use in this IoT kind of a scenario. Okay. So like I said, this ISO meaning 29192 talks about this authenticated encryption. So what does AEAD stand for? Authenticated encryption with associated data, right? So we know that one is this confidentiality, other is this authentication. So these are the two goals which this crypto algorithms are trying to achieve. So can you achieve both encryption as well as confidentiality in one go, right? So in the public key side, there is something called sign encryption. So some of you might be aware of it. In the symmetric key side, what we have is what is called the AEAD, right? Authenticated encryption with associated data. So what is happening here is there is this meaning transfer of this data, and you want to ensure that the confidentiality as well as the authenticity of the data is maintained in one go, right? So the usual recipe is to combine a MAC. So recall that MAC was this message authentication code, which meaning we saw that can be achieved using either a hash function with a key. It's a kind of a keyed hash function, or on the other hand, a block cipher can be used for getting a tag. So you combine a MAC, which is unforgeable. So we need to have a security condition of unforgeability on this MAC together with the encryption scheme. So you want that encryption scheme to be semantically secure. So if you can combine them in a nice way, I mean, combine is somewhat a very ambiguous term. There is a lot of crypto involved in kind of combining this. So if you combine MAC with the encryption scheme, you can get both authentication and confidentiality in one go. Okay. So the Cipher competition, which was run by NIST, was trying to make a portfolio of AEAD schemes, and I think meaning I presume I'm correct about the last bullet. So it has come up with the final portfolio. It contains these many AEAD schemes like ASCON, ACON, AGIS, OCB, etc., etc. Right? So AEAD is a kind of authenticated encryption with associated data. So you can see that authenticated encryption. So authentication is covered as well as confidentiality is covered by this encryption. So the usual way is to combine a MAC with an encryption scheme, but meaning you can have a lot of variants in this also. So all these kind of designs, they kind of achieve whatever is required of this AEAD kind of a meaning requirements, security requirements. Okay. So just to conclude, so some meaning not all, but some of the IoT systems will need confidentiality and authentication. So which you can provide by using crypto primitives. So these devices have resource constraints. So we cannot use whatever you have been using for your server/desktops here. We can continue to use those ideas which we used for designing meaning block ciphers for servers. We can apply them here. So we can use metric keyless ciphers like block ciphers, stream ciphers, hash functions, etc. But we have to kind of tweak our design meaning design paradigms according to what is required, meaning to ensure that the resources required are kind of minimal. And then meaning our favorite topic is this analysis of side channel resistance needs to be verified, namely that your implementation should be in such a way that it's not leaking any other information when it is running. And like I said, pointed out, there are some standards and recommendations which can be used when you are already in a scenario where you have a IoT system and you need to kind of make sure of its confidentiality and authentication. So with this, thank you.
Yeah, thank you, Dr. Prem Lakshman Das. I think we'll take up some Q&A from the participants. So one Q&A which has come is for lightweight algos in the public key algos, are there any other algos, or is it completely based on ECC prevalently?
Are there any public? No, there are many of them. So it need not necessarily be based on ECC. So there is recently there are some PQC based IoT meaning algorithms also. So they will not be based on ECC. So that is not necessary. Yeah. So meaning, for example, you can use plain Diffie-Hellman with the authentication to make sure that you get a AKE, authenticated key agreement. So it need not necessarily involve ellipticals. But meaning, I think what the speaker wants to point out is that the key size will be small. So there are a lot of studies where people are kind of being inclined towards using elliptic curve based diffie-hellman so that you can minimize the key sizes. But exactly whether there is the pros and cons of using plain diffie-hellman versus elliptic curve based diffie-hellman in a particular scenario, needs to be researched actually. So the answer is ECC is not absolutely necessary, but I think it has a lot of advantages. Yes.
Okay.
So,
yeah, thank you, sir. I think thanks for your answer. I think we don't have any more questions from participants. So thank you very much, sir. I think to conclude, I think very thankful that you have nicely covered on IoT-based cryptography, because we all know that IoT devices are completely constraint-based. So surely we need something like a lightweight cryptography for IoT security. And apart from that, the lightweight ciphers what you have covered is really good, sir. Thank you very much for your session.
thank you very much. Thanks to Nalini first. Thanks.
Yeah. Thank you. So we'll move to the next talk by Miss Nalini. She's a project scientist from SETS. So her talk will be on security framework for IoT devices. So let me read out the profile of Harini for your reference. So Miss Nalini is working in hardware security R&D team of SETS, Chennai as a project scientist. She obtained her MTech in digital electronic communication systems from JNTU. She's a member in IETE and published papers in the national and international journals. She received Shri L.V. Prasad Gold Medal and Pratibha Award for Excellence in Academics during her MTech. She also received stipend from Technical Education Quality Improvement Program, that is TECIP, Government of India. Prior to joining SETS, she worked in CSIR 4PI, Bangalore. Her research interests include hardware security, IoT security, cryptography, and efficient realization of secure network systems. That's about Nalini. It's over to you, Nalini. You can start the session.
Yeah. Thank you for the kind introduction, sir. Good afternoon, one and all. So, is my slides are visible?
Yeah, it's visible. I think you can just move around so that we can see it's moving or not.
Yes, sir.
Yeah, it's moving. Perfect.
Good afternoon, one and all. Now we are going to discuss about a security framework for IoT devices. So we will start with the introduction, IoT framework, and some case studies in the IoT security, and what are the security threats in the different layers of IoT architecture. And we will go with the IoT security framework. Finally, we will conclude the section. So first of all, introduction. As we all know that various companies are manufacturing the IoT devices because of cheaper cost of the hardware and open sources software available in the internet. So the huge number of devices and the complexity of networks has made it impossible to secure the data and communication between the devices. Hence, IoT devices have become potentially vulnerable targets for the cyber criminals. So protecting the privacy of users has become another important challenge in the development of the IoT. So the security of each layer on the IoT architecture should be implemented when we are talking about the IoT security. So we'll discuss what are the different layers in the IoT architecture in future slides. So first of all, when you consider the IoT framework, we will have many things: connect, color, learn, and do. So things are nothing but sensors, actuators, RFID tags, like Dr. Prem sir mentioned, RFID tags and all will come under the things. So once we got the things, we have to connect and form a network by using any networking protocols such as Zigbee, Bluetooth, Wi-Fi, LoRa, 6LoWPAN kind of communication protocols. So once we have connected network with the things, we have to collect the data from the sensors. So we can use any SQL or NoSQL database in order to collect the data and store the data. So once we have collected the data, we have to apply machine learning algorithms in order to learn the data, learn from the data, and we can classify the data based on the machine learning algorithms. And we can also find out is there any anomaly in the network by using learning mechanisms. So once we have learned from the data, what we can do is we can improve the quality of service. Like mornings, so many speakers are mentioning like there is like we should guarantee the quality of service. So when we can do is once we learn the data from the things, we can improve the quality of service. And next one is the reduce the consumable cost. So for example, if you had a vehicle you want to change the oil in that one. So what we will do, we will change every 3 months. So instead of doing that one, if you put IoT in the vehicle, so what it will do, it will predict like when the oil can be changed. So in that way, we can reduce the consumable cost. And also in the smart home applications, if you are going to office, you have to control the home applications. So we can use the IoT in that kind of application so that we can reduce the consumable cost. So this is also one of the application of IoT. And the different industries that are providing these IoT framework are things can be provided by using Intel, Sensim Healthcare, like here, Sensim Healthcare, which is used to get the medical devices kind of thing. And we can also use national instruments. And once we got the things, we have to connect the things and form a network. It can be done by any networking protocols like Cisco. We can use Tata Communication. We can also use Telefonica kind of things. And once we connect the things and form a network, we have to collect the data from that devices. That can be done by using Microsoft Azure. We can also use Teradata, MongoDB, Oracle kind of things. Once we have collected the data, we have to learn the things from the data collected. So that can be done by using Keras. I think you all will be knowing like TensorFlow, which will be used in deep learning and machine learning techniques. And also we can go for Amazon Web Services. It is also one of the application which is used to store the data. And once we learn the things from, once we learn the data, what we can do is we can do the automation. So it can be done by using Bosch, one of the application like Z, also one of the industry which is providing the like smart home application kind of thing. So otherwise we can go for IBM also. These are the industries which are providing the IoT framework. So one of the case study is telemedicine palliative care. So why it is like if you want to monitor any heart patient, you can go for telemedicine. So in that we had a forage wearable device which has the heart rate sensor, which will get the heartbeat of the patient, and we can have blood pressure sensor, temperature sensors. By using these sensors, the data which is collected from these sensors will be sent to the like edge computer by using the Bluetooth protocol. Actually, here the heart rate sensor will be the device will be connected to the patient. From that, it will collect the data and send via Bluetooth to the edge computer. Once the edge computer collects the data, it will be connected to the internet by using LAN. So once the data is transferred to the LAN, it will store the data in Azure IoT Hub. So as we have seen here, like Azure is one of the IoT application which is used to collect the data. So here the data will be collected and stored. So once we got the data, what we can do is we can explore more on that one, like how we can provide the services to the patient. So this is the one kind of application. Here where the security issues will come here is, for example, the patient is having a heartbeat of 100 beats per minute. So if the hacker comes into there and if he changes that one to the 200 beats per minute, then what will happen? The doctor will rush into the location thinking that patient is in the trouble. So this is one kind of security issue where we can face in the telemedicine application. So we can see some of the notable case studies, like SonicWall have reported malware attacks are increasingly targeting the healthcare IoT devices. So in recent days during the pandemic also, so many medical devices are attacked by using like vulnerabilities in the medical devices. So this is one of the best example by SonicWall. Next one is the SolarWinds attack, which is also known as a supply chain attack, which shows that like there is a easy way to compromise the thousands of organizations in a one store. So this thing we learned from the SolarWinds attack. This is also one of the most famous attack which is happened in the SolarWinds organization. And another one is a zero-day bug in the Eclipse library. Eclipse library is a popular C library which is used for the embedded systems. So it could leave the IoT devices vulnerable to the DNS poisoning attacks. So these are the some of the few notable case studies where we have to think about the security of the IoT devices. So if you see, actually IoT architecture will differ in different scenarios. So if you this is one of the many of the people will follow this kind of IoT architecture. Some people will follow 3-layer architecture, and some people will follow 5-layer architecture also. So if you consider 4-layer architecture, it will look like this. It will be having sensing layer, which is also known as a perception layer, and then network layer, middleware layer, application layer. In the sensing layer, what we will have is all the sensor like temperature sensor, humidity sensor, pressure sensor, and also we will have the actuators. So in the networking layer, which is used to connect the things to the internet. So by using a Wi-Fi, any routing protocols. So in the middleware layer, we will have the like data storage, like data center, cloud, web service, Amazon Web Services will come under middleware layer. In the application layer, which is nothing but a smart home applications where we are using nowadays. Smart home, smart healthcare, smart buildings will come under application layer. So what are the different security threats in the different layers of the IoT architecture? So first of all, if you see in the application layer, we will have different kind of attacks. First one is the code injection. Code injection, I think you will be knowing, like in any attacker can inject the malware into the device by exploiting the programming errors in the code. And this is also actually by using code injection, the attacker can steal the data, and also sometimes he can get the system control also by exploiting the code injection attack. Next one is the buffer overflow attack. Yeah, like we all know, like buffer overflow attack will happen because of the like code and data buffer, boundary of the code and data buffers. It can also lead to stack and heap overflow. And example for a buffer overflow are like integer errors, and then double free errors also will come under buffer overflow. And phishing attack is nothing but an attacker will act as a real user so that he can get the sensitive data from the real user. Like he will act as like I'm the legitimate user, so that you can provide some sensitive data like the passwords and credit card details and all. He can able to get the details by using phishing attack. So this is happening mainly through the emails. So next one is the sensitive data manipulation. He can manipulate the data. Once he collected the data, he can manipulate and send to the like wherever he needed. And in the middleware layer, we had flooding attack. So we'll see flooding attack. Actually, it is also known as a SYN flooding attack. In TCP, we know like a 3-way handshake is there. One is from client to server, like client will send the SYN request to the server. So then once the SYN request is received by the server, it will send the SYN or acknowledgement to the client. So then client will send the acknowledgement to the server. So this is the 3-way handshake in the TCP. So in SYN flood attack, what will happen is attacker will keep on sending the SYN request to the server, so that it will flood the server, and the actual client won't get the packets. This is one kind of flooding attack in order to flood the network between the client and server. This is also known as a DOS attack, denial of service attack. And then Is Ble attack. Is Ble attack, sorry. In middleware layer, we had signature wrapping attack and SQL injection attack. Also, you will be knowing like SQL injection attack will be done by using the SQL statements like read, write, and then delete operations. In the network layer, we had DOS attack. Good morning, Dr. John Joseph explained about DOS attack, and some of the attacks like MIT, man in the middle attack also, sir has explained. So Is Ble attack, actually DOS attack, MIT attack will come under network layer, and also Is Ble attack. So Is Ble attack is nothing but creating a multiple identities for the single node. For example, if you see here, this is green color one is the honest node, which is having one identity. So in the Is Ble attack, the attacker will create a multiple identity so that the actual node will send the like it will execute the code multiple times, and it will thus it will reduce the defeat the redundancy. So this is one kind of Is Ble attack. Here, if you see in the vehicles also, it will have same identity. This is actually one car, which is the correct car. Like example for this one is like a vehicle having the multiple. What is that number, registration number? So here this car also may manipulate this number plate. So this vehicle also will be having the same number plate, and this vehicle also will be having the same number. He will copy the same number plate so that he will act as it and the owner of that vehicle like that. So this is one kind of simple attack. And in the next one is the sinkhole attack. In the sinkhole attack, CL is the compromised node and SN is the sensor node. What it will do is it will attract the traffic from all the sensor node so that all the traffic will be sent to the compromised node. So here actually sensor node has to send the data to the base station. Instead of that, because of the compromised node sync node, what it will do, all the sensors node will send the traffic to the compromised node. And that sensor node will think like, okay, I have sent the information to the destination node. So this is one kind of the sinkhole attack. So advanced version of sinkhole attacks may lead to black hole, gray hole attacks. These are the attacks in the network layer. In the perception layer, also known as a sensing layer, we have like eavesdropping, RF jamming, tag loading, and spoofing attack. So eavesdropping is nothing but, for example, if you had a user and server, so actual communication will happen like this. So in the eavesdropping, what the hacker will do is he will create a new connection between the client and server. He will eavesdrop the messages going from the user to the server. So this is one kind of the eavesdropping attack. In the RF jamming attack, for example, here this vehicle is getting the signal from the tower, some messages from the tower. What the attacker will do in RF jamming is he will send some unwanted signal or jamming signal to the vehicle so that that receiver will receive some corrupted signal or noise signal. So here, once the vehicle receives the signal, it can't able to identify. He can't like that vehicle can't able to get the correct data because of this noise signal. He will receive some corrupted signal. So this is one kind of RF jamming. So it will be done by using like RF signals and all. And tag cloning, for example, just to start explaining about the RFID tags. In the tag cloning, what will happen is, if you consider the RF reader and RFID tag, so they will clone the RFID tag so that the reader can't able to distinguish which is the valid tag and which is the compromised tag. And in the spoofing attack also, that RFID tag, for example, there is a valid tag. So in the spoofing attack, the attacker what he will do, he will create a tag which is equivalent to the valid tag, so that compromised tag also will get the same permissions and same services as the valid tag is getting. This example for spoofing attack. So after seeing all these kinds of attacks, morning Dr. John Jose also explained like some of the attacks like side channel attacks and all. So after observing these kind of attacks, we are in the need of providing the security at each layer of the IoT. So how can we provide security in the each layer of IoTs? By following some IoT security framework. So here if you see, we know like we had 4 layers mainly: perception layer, middleware layer, network layer, and application layer. In the application layer, the phase of operation will be management and utilization phase. For example, application layer will decide what and all the utilities can be provided to the user. So then data transmission will be done by the networking layer, and data processing can be done by middleware layer. Data collection can be done by the perception layer. So what are the protocols used in the perception layer are Zigbee, Bluetooth, and RFID for RFID readers and RFID tags. And it will also use the IEEE 802.15.4, one of the standard IEEE protocol. And in middleware layer, we can use UDP and TCP. In the networking layer, we will use Wi-Fi, Zigbee, Bluetooth, BLE. Actually, we can use Zigbee, Bluetooth in both the networking layer and perception layer. And we can also use some routing protocols. And we can also use IPv6 in the network layer. So application layer will use the COAP, MQTT, and HTTPS for secure transmission. So actually, if you see in all the layers, there is some low-level inbuilt security in the IoT devices. For example, in the application layer, we had authentication and authorization. Based on this, it will decide what are the Utilities, we have to provide the user based on the identity of that user. And IPsec is for Internet Protocol Security in order to secure the communication between the different layers. And middleware layer will use the SSL, secure socket layer. And also authorization can be used in the perception layer in order to provide the utilities for the user. These are the inbuilt security already there in the different layers of IoT. So what are all the recommended security solution we can provide by following the IoT security framework? We can use a lightweight encryption, as Dr. Prem sir said, like lightweight encryption. We can apply for the devices, Rfid device like that. So we can apply a lightweight cryptography in the perception layer and middleware layer. And we can also use physically unclonable functions in order to key management and all we can do by using puffs and all. And we can use symmetric encryption for the networking layer. We can use robust authentication and access control in order to provide specific utilities for the user based on the authentication. And also we can provide the system access control based on the privileges given to the user. So combining all together, we can use authorization, authentication, and access control for every activity in the different layers of IoT. So one of the research is going on intrusion detection system to include the IDS in the IoT. So if you use IDS like regularly monitoring the IoT devices for is there any anomaly in the network like that, we can find out and we can separate that anomaly from the network so that we can avoid that kind of cyber attacks. And we can also use machine learning and deep learning techniques in the together with the IDS in order to reduce the cyber attacks. So one example is like if you use learning-based authentication, we can reduce the eavesdropping attack. We can avoid the eavesdropping attacks, and we can also avoid the spoofing attacks, Is Ble attacks. And if you use learning-based malware detection, we can easily able to detect any malware is there in the here learning-based. Like we can apply any machine learning or deep learning-based techniques in order to detect malware in the network. And we can, if you detect like any malware in the device, we can separate that one in the network so that it won't be spreaded around the network. And we can use a learning-based access control. If you use learning-based access control, we can mitigate the DOS attacks. And if you use a secure IoT uploading with the learning, we can avoid the man in the middle attacks or jamming attacks also. So finally, conclusion, in the development of IoT, one of the major obstacles is the security and privacy issues. So IoT attacks may cause privacy violation and threaten the people's life. For example, if you take any medical IoT device, if something happened to the medical device, it might harm the people's life. So in that kind of scenarios, we should take care of the privacy issues and data should not be leaked beyond the device. And properly securing the IoT devices is an integral part of any development, particularly in the environment, as I said, like in the medical environment, we should be very careful because as it is transferring the sensitive data like heartbeats and all, like for if you take the heartbeat sensor, so that kind of sensitive information should not leak outside the device. And therefore, it is necessary to consider the IoT architecture as a whole and provide the holistic protections. So if you implement the IoT security for each layer in the IoT architecture, at least we can avoid some of the cyber attacks. And also there is a need of ML and deep learning techniques in order to avoid most of the cyber attacks.
Yeah, thank you, Nalini, for your session on security framework for IoT device. I think any questions? Yeah, I think there is a question from one of the audience. How can we analyze medical IoT data without sending it to the cloud or other storage for security reason?
Sir, can you repeat the question, sir?
How can we analyze medical IoT data without sending it to the cloud or other storage for security reason?
So actually we can use ML techniques, machine learning techniques and AI techniques. But without cloud means we have to maintain separate server. Or like we can maintain our own server instead of sending to the outside cloud. we can maintain a separate server side.
Yeah.
Which is not connected to the internet.
Okay. So I think as she's saying, the answer is isolation. I think that's the only solution because I think nowadays all IoT devices send data to the cloud.
Yeah.
Yeah. Any more questions from the audience or any more questions? Okay. I think let's before moving. Yeah. One more question. Sir? Yeah. Just a minute. What is learning-based authentication?
Hello. So actually, we can apply any machine learning technique. Learning is like, but applying any ML or DL or AI learning methods, algorithms.
Okay. Okay. I hope it has answered the question of the audience. Okay. Fine. Thank you, Nalini. Thanks for nicely covering the case studies and the popular attacks for IoT and your mechanism of layer-wise security mechanism for IoT devices. So it's really good. Thank you very much for your session.
Yeah, thank you for giving me this opportunity. Thank you, audience.
Okay, then we'll move to the next session. I think next talk is by myself. I think, sir, can you give me the sharing option? No, I want. Yeah. I hope it's visible. Yes, it's visible. Yeah. Thank you very much. I think good afternoon, everyone. My name is Shrikant, and I'm working with CDAC from last 18 plus years. So I have started my career working on various things like wireless sensor networks, where we were developing the efficient, power efficient routing protocols, and so later on we moved to something called as ubiquitous computing. I think you might have heard about it, where it is anytime, anywhere, any place computing, given by Mark Wieser. So we started developing the applications on ubiquitous computing. So now we have moved towards IoT, so which is Internet of Things, and we started developing various applications for smart cities and so. But recently we have added a feather to a cap. Team is working on something called as IoT security, where we are setting up a lab for IoT security and even putting up procedures which is supported by STQC. So my session today would be on IoT device pen testing. I think you all know pen testing is generally we call it as VAPT, that is vulnerability assessment and penetration testing. So I'll be more focusing on that. So my session would be something IoT device pen testing in and out of the box. So I'll be giving you the various mechanisms, various tools available in the market, how to do it because of the time constraint of around 30-40 minutes. So I'll not be going intensively because we can take up this session somewhere where we can take an intensive workshop on this penetration testing, but I'll give you an overview of the pen testing, different mechanisms and different tools. Okay. So let me start off like this. I think a lot of people have said that IoT billions of devices have come up in the market and they have become a part and a parcel of our life. So IoT is changing everything, am I right? The way we communicate, the way we work together and all. So, but the thing is, first question, if you want to answer, see, if you look at this comic where they have said, did you know the S in IoT is for security? But we know that a lot of manufacturers, a lot of vendors, a lot of OEMs, they generally say, even developers like us, who say that there is no S in IoT. Exactly, that's the point of discussion today. That is where we need to talk about the mechanism, the tools which we use for IoT pen testing today. Okay. So my session would be something like this. The agenda for today's session would be something. I'll start off with why we are here, why we are sitting together here, listening to this session on IoT pen testing for IoT security, and then what exactly are the mechanisms, what exactly is IoT, where we can, what is surface attack surface mapping, what are the tools which are available in the market. I'll be more focusing on the open source tools because there are a lot of tools which have come up into the market which are proprietary in nature, but there are open source tools which does a better job for us. So that's what I'll talk about them today. And who are the end beneficiaries and all, who will be doing this pen testing and all? Anyone, I think if ethically they want to do, they can take up this because I would say that when you talk about IoT security, it has created a new field in the market today for engineers like us. So where it has given us opportunity for two things. One is building the thing and one is breaking the thing. One is building where there are any vulnerabilities, you can develop softwares to mitigate those vulnerabilities. You can develop patches to mitigate those vulnerabilities. But at the same point of time, you can work as an ethical hacker where you can break into the system, find out vulnerabilities, and surely intimate the vendors. So which will benefit the whole nation as well. So that is what, and how is one we are going to focus today basically, because how is what exactly are the tools going to do, how do we install those tools, and how we are going to attack attack into the IoT device and do the VAPT. So that is going to be our session today. So this is my agenda. In the next half an hour I'm going to discuss this. Yeah. So the first question is motivation point. I think a lot of people have given this, but still I wanted to give you a line of motivation here. Why we should be concerned about IoT. So the concern about IoT is, as I think a lot of speakers have said, that they are nothing but small computers which are put up into the network. So when I talk about a computer, generally what happens is computer has a lot of issues like access control, vulnerability management, patching, monitoring, and so. In the same way, because IoT might be a lightweight, a constrained device, even IoT may be having all these constraints which come up into nature like access control, vulnerability management, patching, and monitoring. So the thing is, if I imagine that I put up, because today IoT device, people are talking about billions of devices coming up into the network. If I put up around 1 million of devices into my network, and even one device gets compromised, what's going to happen? So it's not going to breach into your organization, it may be breaching into your house also. Because on average, as Chidambaram sir said, on an average, we have 8 to 10 devices at home, according to the survey. So these 8 to 10 devices, even one device gets compromised, the hacker is going to get, he's going to enter into your house, or he's going to enter into your organization. So this is the point of concern we have for IoT today. So the thing is, the biggest concern more about IoT is generally a lot of people talk about IoT security, IoT security, that like a lot of protocols can come up into the picture and all those things. But the problem is, when I'm talking about as a pen tester, my problem with IoT security is IoT is a domain which is multidisciplinary. That means I can't say that the security of IoT should be at the hardware, the security of IoT should be at the software, or the security of IoT should be on the cloud or the online elements. I would say that the security should be everywhere. So that's the point of concern today. And the biggest problem with IoT security today is business models which are available in the market for the vendors or the manufacturers, they don't support good security basically, because time to market is the most important component that's going to hit security component as a whole. And apart from that, if you look at till now, IoT vendors, they don't have this culture of security, adding up security basically. They don't have that S component into their security. And one more thing is IoT device, lot of IoT device coming up into the market, we deploy at home, we deploy in the organizations, they don't have proper security updates. So when there is a vulnerability, there's an access to your network basically. So this is the point of concern of my session today. So that's why we are going to discuss. So what could possibly go wrong? So that's the biggest question a lot of people ask. What could possibly go wrong is I think the best example anyone would have given is the Mirai botnet. I think in 2016-17, you know about the Mirai botnet, the botnet malware, which has made your popular websites such as Netflix, Reddit, and all. They made it offline because of the botnet malware, which was available, just because of people using IP cameras with default credentials basically. So that was the biggest problem which was happening there. So the next example which we are going to talk about, which has made the complete IoT today concern is, I think you might have heard about criminals hacked a fish tank to steal data from a casino. The thing is, a small temperature sensor, that means I would say that an innocent, insecure temperature sensor has allowed the hacker to get into the fish tank, which has given the complete rolling database of the casino. So that was the biggest issue which has happened. And I think this was about a North American casino, which has happened basically. So there are a lot of examples I can give you, a lot of examples like the pacemakers, lot of dolls where they were overhearing kids' conversations and all those things. And even we heard about the Jeep hack which has happened. So this is the major problem of concern today. And if you look at the 5 worst IoT breaches which has happened is, I think already we have spoken about Mirai botnet, that hackable cardiac device from St. Jude. St. Jude, these devices, they were pacemakers which were put up to control the heart attacks and to control the strokes. So the transmitter which was there, the transmitter was vulnerable. So because of that, it was storing the data which was storing to the physician, the data. So they have breached into that. They were able to make the changes into that. Like that, you might have heard about the Jeep hack, just because it had a Uconnect Uconnect onboard device which was connected to the network of for security updates basically. So just because of security updates or firmware updates, they were able to get into the network and do it. So keeping all this in mind, I think I think we'll get into the next thing. The next question is what exactly we are going to do today. So for getting into what exactly we are going to do today is, the first thing is I want to just define what is an IoT device. An IoT device, I would say that I think a lot of people have given a definition that a new name given to embedded systems. A new name given to embedded systems. Okay, that is one definition which is for IoT. So they generally say that all these embedded systems are already there. They have become a part of our life, basically part of our system and part of our organizations. But what is the difference between an embedded system and IoT basically? So the thing is, if you look at an embedded system, if an embedded system, all these days you might have seen standalone embedded systems, network embedded systems and all. But they say that an embedded system getting connected to internet, we call it as an IoT basically. We call it as an IoT, but there are different definitions that embedded systems, these embedded systems are generally run on batteries. They're having low power, low memory, and they can be considered as constrained devices basically. So if you look at the different components of an embedded system is just a hardware which will have a controller, it will have sensors, actuators, and finally the data is going to go onto the internet basically. And data is going to go onto the internet to share the sensing data so that you can take an action. So if you look at the popular examples, I would say that I think I need not tell about them. Already you know about these devices. Amazon Alexa is there, Samsung Smart TV is there, Google Home is there, Nest is there. So many devices. To name a few, these are the devices. But I think you may be having more devices than them. But generally, if you look at an IoT, always we see that they are generally labeled as smart devices. Smart devices. Smart is a word which is given to them because the data is going to the cloud, and from the cloud you are going to actuate the device basically. So this is what generally people call it an embedded system. But recently, if you look at an IoT device generally we talk about something called as a firmware in an IoT device. So a lot of people generally what happens is there can be bare metal IoT device, and there can be some devices where you have a small embedded OS taking care of the activities in your IoT device basically. So that is what, and generally if you look at an IoT device, generally it is generally called as a non-standard devices, because generally IoT devices are not generally what you talk about like your mobile phones, not the device like your laptops, tabs, desktops and so on. So there are a bit of non-standard devices which are more constrained in nature. Okay, keeping that in mind, just I'm telling these things because we are going to learn how to attack these components basically. That is what we are going to learn today. So the thing is, when I talk about an IoT device, as I clearly told you that it's divided into three components. One is generally the sensors, the second thing is the connectivity, and third thing is the process. People in the process, that is the cloud component. And there is a fourth component which is generally hidden, that is generally called as an actuator basically. Because generally if you look at a sensor and actuator, sensor is the one which is generally giving the input, actuators are the one which are going to take up the output and take an action basically. So these are the three major components which we need to know, because in an IoT ecosystem, these are the one which are going to come into picture when we are going to do something called as a attack surface mapping. Okay, so just to give you a glimpse on what sensors are, as I clearly told you that depending on your application, you can have the respective sensor. Today I have an IoT device in this room. I want to know the temperature of this room. What generally I do, I put up a temperature sensor. I put up a humidity sensor if I want a humidity of it. If you want to know the pollution in the market, you will put up generally what you do, you put up chemical or gas sensors basically, which are put up. Any leakage, you will put up the leakage sensors. Like that, you put up different sensors for different applications basically. So this forms the input for your IoT system. So when this forms the input for your IoT system, the next component is the actuator component. Actuator component, as I clearly told you that sensor plus actuator, generally what happens is sensors gives the input, actuators generally take up the output basically for you guys, which take an action for you. Okay, just like connected lights or anything. Based on there are no people in this conference room, generally lights may be off. Whenever people are coming into the conference room, like a proximity sensor may be there, which can turn on the lights basically. So these are some examples what we can talk about IoT devices as a whole. So connectivity, as I clearly told you that this is one of the major component. I think my colleagues will be talking about how to exploit this connectivity, because Bluetooth is one thing that is we call it as BLE, Bluetooth Low Energy. That is one important protocol, because generally for home applications, indoor applications, Bluetooth play a big role, Wi-Fi plays a big role. But generally for outdoor applications and all, generally whenever I'm talking about IoT, today new protocols are coming up into the market, like LPWAN protocols, like LPWAN, which these protocols are low power wide area networks, generally LoRa, NB-IoT, Sigfox, Telenza. All these protocols generally fall onto this component basically. So this is one area where you can get into if you want to find out the vulnerabilities. Okay, so this is the second component what I'm going to talk about. And the third component is the cloud component. I think generally once the data comes onto the cloud, what generally happens, So this is what generally what you do is all the data aggregation, data you can data aggregate, you can analyze the data and give the outputs basically. So these are the three major components when I talk about an IoT applications or IoT ecosystem. But as I clearly told you that actuator is not mandatory component. It depends on application to application basically. It depends on application to application. So the next is if you look at the complete IoT ecosystem as a whole. So IoT ecosystem as a whole, as I clearly told you that the first component will be the end devices. End devices generally has the sensors, actuators, and so these are nothing but small embedded devices which are put up. Then generally what happens is depending on your network, depending on your range, you can have a gateway in the middle. So gateways also generally play a role because these IoT nodes which are there, they are generally most of them are battery operated basically. Most of them are battery operated. So and they are constrained devices. So generally you have a gateway in the middle, which is more main part. So generally gateway can take up the data from the IoT device. From the gateways, it can go to the cloud because gateway can have a, because we all know that gateway is a protocol translator. The one way you can have a Bluetooth or Zigbee or any other protocol, and gateway can translate it into 3G, 4G to send it to the cloud basically. So these are the various components we have in an IoT ecosystem. Just keep this in mind. These are the components which are there in the ecosystem, and communication play a big role in this IoT ecosystem. Okay. So if we look at these IoT components, if I decrypt it further, basically decrypt it further, the thing is there are various components. As I clearly told you that they are sensors. You can these sensors are integrated to a controller. We call it as a microcontroller. Basically, it can be ARM based, MIPS based, or so and so. And there will be a communication interface which will be integrated to the controller. And finally, what happens is this becomes the IoT node. From there, the data goes to the gateway. From there, it goes to the cloud. From there, it can goes to the various applications, or you can have a mobile apps in the middle. And recently, a new flavor has added into IoT, which is nothing but voice user interfaces. I think you might have all heard about Alexa, Google Home Assistant, Siri. So many things have come up basically. Just I want to tell it, it has to do that. So these are the various components which I would say that will be there in IoT components if we decrypt it further. So you may be asking me a question, sir, why about all these things we are discussing? The thing is, can you guys tell me where would I provide security for IoT? I would say that security should be everywhere. Any small vulnerability in the middle, it can any hacker can get into your network, any hacker can get into your system basically, complete system. So that is what I would like to claim. And now you guys tell me which way would you attack IoT basically? Where would I attack IoT? Because as a pen tester today, because as a pen tester and I'm taking this session today, so you tell me where would I attack IoT? Will I attack IoT at the endpoint? Will I attack IoT at the gateways? Will I attack IoT at the cloud? I would say that I think we have to get into detail of this. Let's see where would we attack IoT basically. Okay. So for that, the first thing any pen tester, if he wants to do any attack onto IoT, the first component we have to do is we have to know what are the previous IoT security issues. Because these are the IoT devices which are very much trending in the market, very much famous into the market. So if we look at the previous IoT security issues, the first issue which I would talk about is the Nest thermostat. I'll not explain all the things. I'll just talk about Nest thermostat. Nest thermostat, I think you might have all heard. This is a thermostat which is put up in the home to control the temperature of your house. This is taken up by Google now. This is called as Google thermostat today, Google Nest thermostat. So the biggest problem with Nest thermostat is, the thing is, there is a global reset button on the Nest thermostat. When I press the global reset button, generally what happens is immediately the device, the IoT device which is there, it starts looking for some USB media basically, the USB media. So if I insert a USB media, which is having a malicious firmware basically, so the device will again reboot with that malicious firmware. So the device will play around as you need, as the hacker wants to do it. Unintended services can be done over that binary basically. So that is the problem with Nest thermostat. And one more problem, if you want to talk about Nest thermostat, is what they say is the thing is the SSID which is there for SID is generally service set identifier, which you generally use it for Wi-Fi basically. So generally you can customize that SSID and send it over the network. Generally what happens is because of that customized SSID, generally they say that Nest thermostat or Nest camera basically, Nest camera I would talk about, Nest camera, it generally reboots. So whenever it reboots, generally they say that it will take around 90 seconds to reboot. in 90 seconds, while rebooting, any burglar can get into your house basically. Any burglar can get into our house. So that is the example I would take about. That is the reason any device which is coming into the market has to be pen tested well. So how do we do this vulnerability assessment and pen testing will be the next part of my session today. So performing an IoT pen test. So whenever I talk about performing an IoT pen test, so the thing is, the first thing what we need to talk about is, generally what people talk about is, the first element of any IoT pen test is attack surface mapping. Attack surface. So what exactly is attack surface mapping? So what exactly is IoT pen testing? So the definition generally, if you look at, I think I have picked it from Aditya Gupta's book. So what he says is an IoT penetration test is the assessment and exploitation of various components present in an IoT device solution to help make device more secure basically. So he's also saying that it's nothing but assessing all the components which are there in the IoT, complete IoT device solution, that is IoT ecosystem basically. So we have to analyze them, we have to assess them and try to exploit them so that there are no vulnerabilities basically. It's not to hack into any system or any network, but what he's saying is to help the vendor to make the device more secure basically. So the thing is, what exactly we have to do? What are the steps involved in this? Is first, any pen testing, any device you want to pen test, first I want to understand the scope of the device basically. So first, understanding the scope of the device is what are the components on that device? What are the components on the device and all? Generally, what happens is any device comes. So generally, we also look at is it black box testing, is it a white box testing, or is it the gray box testing basically? So generally, black box testing, I can take off-the-shelf devices. I can take the device and do. I can take the device. I can understand what I can do something called as a reconnaissance, where I'll be taking up all the data sheets. I'll be reading a lot of documents about that device and coming out with the scope of the device basically. Coming out with the scope of the device, that's a black box basically, where vendor is not coming up into picture. But if vendor is there, you can get more information basically, lot more information from the vendor because he is the manufacturer of the device. He knows what are the components, various components in there. So there we do something called white box. It's more rigorous testing basically. Okay. So the thing is, first after understanding the scope, the first step I'll do is attack surface mapping. So the question is, how do you define attack surface mapping? Attack surface mapping, I would say that is nothing but attack surface mapping is mapping of all the components available on the IoT device solution wherever and the hacker can abuse the system basically. So these are the complete components. These are the entry points where the hacker can abuse the complete IoT system. So that is a general thing. That is the reason we need to come out with all the components available on the IoT system so that we get a complete attack surface mapping. We don't miss anything basically. After that, what we need to do, we need to come out with a vulnerability assessment and exploitation. So now the question comes is, what is the vulnerability? A lot of people have, because we talk generally, we loosely use the word called vulnerability basically. What exactly is a vulnerability? Vulnerability is generally, if you look at the definition of vulnerability, generally they say that it's a bug in a binary that can be leveraged with an exploit basically. It's a bug in a binary that can be leveraged with an exploit. So now the question comes is, what is an exploit basically? So what is an exploit? Generally, when I talk about exploit, is nothing but I would say that it's a customized or a crafted, crafted modification that you can do it so that you can utilize the vulnerability. You can utilize the vulnerability. Okay, you can utilize the vulnerability and get into the binary and make the binary do unintended activities basically. So that's an exploit, I would say. That's an exploit, so that a binary will play according to the hacker base. So all the unintended, what it is supposed to be, it will not be doing that. All the unintended activities, it will be doing it for you guys. So once that is done, once the vulnerability assessment and exploitation is done, so that we have to do with the various tools, various tools we need to do the vulnerability assessment, and even exploiting we have to do with various tools that we'll be discussing in brief. And finally, you need to document the complete report basically. Complete a report and give a report of whether there are vulnerabilities available in the IoT device or not. So all those things we can give it to the manufacturer. So this is what exactly an IoT pen test is. So if I want to do the IoT pen test, as I clearly told you, the first element is attack surface. Now you guys tell me, what is the attack surface for an IoT device solution? If I look at the IoT surface, I have hardware, because hardware is there. I think there is a firmware. Surely there will be a firmware because what actions your hardware has to take, a firmware will dictate. Am I right? So then you have a network because your IoT devices are connected to the cloud, because as I clearly told you that embedded systems connected to internet is IoT. So network should be there. You can have wireless communications. You can have mobile and web applications to control the device. And finally, the data is going to the cloud. You may be having cloud APIs. So generally, whenever I take up a device, the first thing is I'll make an architecture basically like this. So what is the device? I'll be looking at all the documents available, possible documents. Generally keep in mind, partial information, partial documentation is not the right step for doing penetration. You need to have a full picture of the device. Then only you'll be able to properly take up the device and do an attack surface. So generally what happens is you take up the device, you first take up a architecture of the complete device basically, like whether it has a gateway, what is the device, what are the communication protocol which it is using, what is the gateway it is having, what is the cloud dashboard, whether there are any mobile applications or web applications it has, when is the data going to the cloud, all those things I'll give a complete picture basically. So once the attack surface is done, what is my next step is, nothing is, now the question comes is, sir, can I do pen testing? I don't have a device with me now. Can I do a pen testing? The device is not there. Can I do a pen testing? Yes. I think today we are going to talk about 3 strategies for pen testing. One is I don't have a device. I have a device. My device is connected. So what do I do with it? So let's start with the first thing is I don't have a device with me. Still, I can do a sort of pen testing. What is that? How do you do it? Is the first thing is I can do with the help of something called as a firmware. When I don't have a device, what do I do is I can get the firmware basically. Today, you all know that all these manufacturers put their firmware on their websites basically. Why do they put? Just because they want to update. They are providing some sorts of an updates basically. So before that, let's talk about what is a firmware basically. What is a firmware? As I clearly told you that I think that this is coined by Asher Opler. So he termed this word firmware in 1967. So what exactly is a firmware? Firmware, I would say that in today's scenario, a lot of people call it as an embedded operating system. Is called a firmware basically, because you have to interact with your hardware, you have to interact with your sensors. How do you do that? That is with the help of a firmware. So what exactly a firmware is? Firmware is, I would say it's a set of instructions which a manufacturer or a vendor wants his device to do. So that is the definition of a firmware basically. Firmware. So generally, how do you get an update to the firmware? Generally, what happens is, why do you need updates to the firmware? Generally, if the vendor wants to fix the bugs because there are some vulnerabilities or bugs previously, so you want to fix it, or he want to roll out some new features, or if he wants to improve the security. So these are the things, these are the times when you get an update. Generally, if you look at your mobile phone, like your Apple phone or Android, generally gets an update when a vendor wants to fix the bugs, or he wants to roll out new features, or he wants to improve security. These are general conditions. It can be a number of conditions basically. Generally, how does they happen? Sometimes they happen automatically. You'll get it on your mobile phone that there is an update. You just say okay, then it will automatically install from the server. The second method is manually. So you go to their website, you go to the vendor's website, you see that there is an update, you have to manually download it and push it onto your device basically. So these are the two mechanisms which are generally available in the market today. But a way to get the firmware, because as I clearly told you now that without device you can do it. But way to get the firmware, sometimes you have a device, you can dump it from the device memory. The second thing, as I clearly told you, that you can download it from manufacturer's server, either through FTP or a lot of things, or you can directly download them, or you can get a CD or a DVD. And sometimes what even pen testers do is they take up the Wireshark traces basically whenever firmware update is happening. That time also you can get a firmware. So these are the 4 options which you have to get the firmware onto your device basically, or you can download the firmware. So once you get the firmware, now you may be asking me a question, sir, what do you do with the firmware? What are the components of a firmware? The components of a firmware is, generally what happens is, if you look at the components of the firmware, this is the general thing. If you look at, I'm talking about the Linux firmware. If you look at, because generally embedded Linux, we generally talk about. So if you look at, there's a boot ROM. Boot ROM, we all know that it's a piece of code which is put up by the manufacturer in the read-only memory. So that is the point of start whenever I do a reset. So from there, it will pick up the bootloader, the respective bootloader, whatever is there. I think we all know there are very famous bootloaders in the market today, like a U-boot, Red Boot, am I right? So many bootloaders are there. So the bootloader, generally the advantage with the bootloader is it is the one which is going to find and load the kernel. Am I right? It is going to load the kernel. But apart from that, bootloader, I think if you look at it, it has special commands where you can debug, and apart from that, you can modify the kernel environment also. So that is the reason we need to know about the bootloader also. Okay, bootloader. And finally, we have the kernel component. In the kernel component, you have the root file system where all your binaries and all and so can be there. So this is the reason we need to know about the components of the firmware. Once I know the components of the firmware, the first question I ask is, why examine the firmware? Why examine the firmware is, I would say that, as I clearly told you, that if you can control the firmware, you can control the device. Very clear. So that's the first thing. Because I have the control over the firmware, I can modify it, I can have the control of the device and make the device do my actions basically. And apart from that, apart from the survey, a lot of surveys say that many vulnerabilities found in IoT devices, they are originated in firmware. Very clear. And one more thing is, firmware, if you get the access of the firmware, the best part is I can look into and see how the configurations are there, how the device is working, a lot of things basically. And I would say that firmware is one of the entry point for an attacker to enter into the network. So because of this, that is the reason the first important component for me is the firmware. If I get the firmware, I can do a number of actions. Yeah. So what can I find by looking at the firmware? Yes, surely I would say that firmware, you can have a lot of things inside the firmware. You can have some hard-coded credentials like the default passwords, and so you can find out any keys are there, what are the encryption and decryption keys are there, any network values to connect to the server, like the default IPs and all which are available. And apart from that, you can find out any sensitive information, whether it's encrypted or not encrypted. And finally, I would also know that whether updates are encrypted or not verified basically, so that I can do a man-in-the-middle attack. I can do while the updates are happening. I can pick up the firmware and put up the malicious firmware basically, or the rogue firmware, whatever you call it. So this is the reason. This is the reason I have to first look at the firmware. So this is what I can get when I look at the firmware. I can look at the firmware. So apart from that, one more component I would say that I think a lot of people said, even S2QC Suresh Chandra sir was saying that they are following OWASP ISVS basically, because OWASP ISVS has given a top 10 issues which are available for IoT devices. So if you look at all the top 10, most of them, I think I would say around 6 to 7 or 7 to 8 are based on firmware attacks or based on firmware vulnerabilities only. So that is the reason firmware plays a very big role in your IoT devices basically, whenever I'm doing my penetration testing. Okay. So the thing is, the next component I need to do is, what sort of analysis you want to do with the firmware? What sort of analysis? Because I'll have two categories of analysis. One is, I would say, that static analysis. The second is dynamic analysis. So the next question is, what is static analysis? I would say that static analysis is, I will be looking at the firmware when the device is not in operation. When the device is not in operation, I want to look at the firmware. So what you would do with the firmware is, I would try to analyze the file system. I would try to inspect the bootloader. I can stop the bootloader and look at what is happening in that, and whether there are any hard-coded items and all these things, like any default passwords are there, sensitive keys are there, and all these things. All these things I can look at. So what are the general tools which are available for this is, generally for static analysis, I have one of the famous tool which is called binwalk, and one is called firmwalker basically. So binwalk is the first step where we extract the file system, and the second thing is extract the firmware. Then firmwalker is the one which is an extension to binwalk. After extracting the complete firmware, you can analyze the thing if you don't want to do it manually. Firmwalker will help you to do it automatically basically. So it will find out the default passwords or what are the services which are it's being used and all those things basically. So the next component is dynamic analysis. Dynamic analysis is very clear. It's just opposite of that static, which says that whenever there is a device in operation, that means I need to have a device on for doing a dynamic analysis basically. So I'll look at the firmware while it is in operation. So the device should be practically on to do that. So some people may ask, sir, I don't have the device. How can I do it? Yes, still you can do it if you want to virtualize the device. So there are a lot of tools which have come up into the market like Kimu and all, which help you to virtualize the IoT device. You can virtually do it also. Virtually do it without having the practical IoT device with you. So the tools generally used for dynamic analysis is Permadyne is one of the famous open source. Metasploit is there. Metasploit, there are both trial versions and even proprietary, Nmap and all. They're open basically. So you can do it. So the thing is, how to perform the static analysis? Very clear. The first step is get the firmware. That is very important. I have to get the firmware either from the vendor's website or dump it from the memory or n number of methods. Then extract the file system using a binwalk. then you have to uncompress the file system to see the components if needed. Why you have to uncompress? That is the question basically. Generally, what happens? IoT devices are constrained devices which are having low memory basically. So generally, all these file systems and all they come compressed. So you have to uncompress it. So later, once you uncompress it, and what you can do is you can look at the common issues such as the file system into the file system, such as the passwords, any IPs and keys and all. Okay, and finally you can look at all the various binaries which are available in the file system to find out the vulnerabilities in that. This is how you do a static analysis. But if I want to do the dynamic analysis, yes, it's very clear that you need to have a device or you have to virtualize the device using Chemo and all. So the famous tools which are available are Firmware or FAT, Nmap, Metasploit, Wireshark and all. You can do the network analysis and so for dynamic analysis. So this is how you do it. So let's get into the tools basically. The firmware analysis tools. The most famous available tools which are there. I'm talking about only open source, sir. There can be a lot of proprietary tools which may be much better than this, but we worked on these open source tools. I'll be talking about only them. So the first thing is the Binwalk, Firmwalker, Firmware, and FAT. FAT is just an extension of Firmware because that automates Firmware basically. Okay. So let's talk about the first thing, that is Binwalk. So before getting to the Binwalk, as I clearly told you that you can download the firmware from different websites. This is a sample I have given from TP-Link website. This is how the download will be available for the firmware for an update basically. You can download it and push it onto your TP-Link cameras and so basically, or routers, whichever it is related to. So the thing is, after doing the first step, that is that. So the first tool we are going to talk about is the Binwalk. The Binwalk, this is the download link where you can get a Binwalk is. So Binwalk, the advantage with Binwalk is it will completely extract the firmware image so that you can identify different files, different information available in the binaries basically. So what it does is it uses a library called libmagic library. Libmagic library, and what it does is it will generally look for the magic bytes available for different files basically. So these are the general magic bytes, which based on that, it will understand that this is a compressed image like a LZMA image, this is CrashFS file system and so. So these are the magic bytes which it looks for basically. So these generally give us the file signatures which are related to those files. So that is how Binwalk works. So if you look at the Binwalk, so generally what happens is, generally whenever I type a Binwalk with the firmware, I get this information. Generally the first step any pen tester should do if you want to learn about Binwalk is Binwalk help you can do. So where you will get all the options of the Binwalk. So, but the most important options, if you look at the Binwalk, is the first thing is Binwalk -E, the firmware name, where it will extract the firmware and give you all the different components in the firmware. It will extract and give you all that thing. And apart from that, it will extract and give you something like this, where you can look at the different components of it. But one thing is, one more component which people look at is, because nowadays all these firmwares are compressed or encrypted basically. But if I want to know whether it's compressed or encrypted, so it will be the option Binwalk -E. So it will give me the entropy analysis basically. Entropy analysis, it will tell me whether it's compressed or it's encrypted basically. If it is encrypted, well to do. You can't really get into the system basically. That's the best part. Initially, only you can look at the entropy and find out whether it's encrypted or compressed. So that's how Binwalk is. A lot of options are there. I don't want to get into each and every option because of time limit. The next thing is Firmwalker. Firmwalker is a script. So after you do Binwalk, you have extract the thing. So what you need to do? So Binwalk doesn't help you to look into the binaries and all those things. You have to manually do it. So you have to hunt for the vulnerabilities manually. But if you say that I don't want to hunt for the vulnerabilities manually, you can use Firmwalker. Take that extracted thing from the Binwalk. You can run Firmwalker. It will help you to look at these what are these locations like etc shadow or etc password, where default passwords are put up. It will look at different binaries, like what are the services available, like whether you are using some legacy protocols such as FTP or Telnet and all, because Telnet, FTP and all are not secured basically, so that you can easily get into the network. This gives the information to the hacker that this guy is using Telnet, this guy is using FTP, I can easily get into this. So a lot of things, lot of URLs, email addresses, IP addresses, all you can find out with the help of Firmwalker basically. So that is about the Firmwalker. Firmwalker, this is how you can see it in the Firmwalker. Whenever I do a Firmwalker, this is how you get. When I do the cat binaries, it will show all the protocols which are generally being followed, the locations where the passwords are, default passwords are there, the IP addresses where you generally connect to the server, and all those information. Okay, that is about the firmware. Then I go to the next tool, that is what is called as Firmware. Firmware, till now I was talking about static analysis. Firmware helps me to do even dynamic analysis basically. Generally for Linux based embedded firmware, it helps me to do that. But the thing is, Firmware also helps me to do something called virtualization, that is emulation of your hardware. It emulates my hardware basically. So it makes uses of two tools internally. One is binwalk for extraction and QEMU for emulation. So generally people say that installing Firmware is not straightforward. So there are a lot of dependencies are there for Firmware to install. So what generally happens is there is a tool called FAT, Firmware Analysis Toolkit. This will directly help you. To install Firmware automatically. It's a small script. You have to just say fat.py, the firmware file. It will automatically install Firmware for you guys. So internally it will even emulate and give you the, so that you can play around with the and find out the vulnerabilities. So these are the tools which are available. That is without the device you are able to do. But with the device, I just want to give a glimpse because I think time is running out. I'll just give a glimpse. If I have a device, what are the best things I can do? So when I have a device, the thing is, first I'll be looking at any internal communication protocols are available, are exposed, are open ports exposed like UART, I2C, SPI, JTAG and all that. And JTAG debugging is there in that. And is it possible to dump the firmware from the flash or EEPROM memory? And apart from that, any tampering can be done onto it, so that I can get into the device, look at what are the components of the device, and easily understand the pins and take out the information. So the thing is, if you look at the physical device, whenever a physical device is with me, I can do something called, there are various methods like invasive methods and non-invasive methods. So if you look at the invasive method, the thing is, first thing I'll do is I'll open the box, I'll find out the components, I'll do pinout reversing to find out various components, because sometimes the skill screen won't be visible directly. The pins can be here and there. So you have to find out with them by putting up various devices like the multimeter, oscilloscopes and so, and try to connect to those interfaces, retrieve the binaries that the firmware, and do reverse fuzzing, or I can do reverse engineering or fuzzing, modify the firmware. I do exploitation and again push back the firmware into that. So if all these things are possible for me, then surely your device is vulnerable. So that is what, as a pen tester, I'll be trying to look into. So the thing is, if you look at the popular interfaces on IoT device, if you look at, I think four famous, I would say that is, one is the UART. Yes, surely a lot of devices today have UART, because that's a serial communication of where you can see the boot log and so. So UART is generally where through UART you get the console where you can see all your functions basically. Then there is something called SPI. Then you have I2C, JTAG. So generally what happens is, generally we all know these are the diagrams, pin diagrams for all the interfaces. I'll be looking at whether these pins are available onto the thing. Whether these things are available onto the things. So that is what I look at basically. Okay, so that is how I look at and come out whether UART is available, SPI is available, I2C is available, or JTAG is available basically. So I don't want to get into this because I think it requires a detailed explaining of all these things. But just keep that in mind. Generally, this is how the firmware extraction happens using UART basically. The first thing is whether UART pins are available. I need to first understand the UART protocol. UART pins are available. I can use some tools. There are a lot of tools available in the market like USB TTL converter, JTagulator today. You have a bus pirates. So many are there. I can connect these devices to my host PCs, and there is a tool called PuTTY where I can get it's like a serial emulation. PuTTY is generally used for open serial emulator, it's called. So I can push the data onto the PuTTY, and you can get the complete U-boot console where you can get the root shell and so basically. So it's not pretty straightforward, but this is the procedure which is generally followed for firmware extraction using these various interfaces such as UART and so. Okay. So that is what generally for identifying the UART pins and all. I think there are various methods. There are various tools available in the market also today. So you can use all these methods. I think the best part would be that if you have some sort of tools like a bus pirate, JTagulator, Shikra and all, it eases your job basically. It basically eases your job so that you can get the data onto the UART. Okay. So the thing is, if I look at, I think there are various, this is how devices look like when you connect your IoT device, when you want to do a invasive penetration testing. This is how it looks like basically. So if you want to dump the firmware from SPI, yes, you have bus pirate and so where through which you can do. But one thing I want to say that is, as I'm telling, it's not as simple as you think, because there will be various mechanisms. No one keeps it straightforward because there are a lot of devices. Even our team struggled getting into the pins and coming out with the data. So it's not a straightforward, and there is nothing called one glove fits all, because it's not a simple solution. But you need to struggle to get into the device and come out with the things basically. But only thing is, these devices help you to smoothen your job. That is what I can say. Yeah. So there are various hardware tools. As I clearly told you that there is something called JTAG, Bus Pirate, HackRF. HackRF is generally for RF communication, radio communication. Zigbee sniffer, Ubertooth is generally for Bluetooth, and so. Chip is for it's generally for side channel analysis and all those things. If you want to look at the power levels and all those things, like electromagnetic waves and all. So these things help you basically. So this is about the hardware tools, and finally connected device. When your device is connected to the network, I think I'll not explain about this because my colleagues are already waiting to explain about this. So generally, if you look at the radio security analysis, exploitation can happen on various communication protocols, such as if your device has Bluetooth, Zigbee, LoRa, 6LoWPAN, so many things can happen. You can sniff into the packets, jam into the packets, modify, do replay attacks, and all these things can happen. I think more explanation will be given by my colleagues, so I'll not touch upon this at this point of time. So if you look at the survey which has happened, I think one scientist from Birmingham, he has done a survey of 24 trending IoT devices into the market, like Amazon Echo, smart bulbs, and all those things. So he found out that UART is the reason whenever UART is exposed, UART is open, 45.83% you can easily extract the firmware. So that is what he says. And JTAG helps us to do it 12.5%. That is EMMC dump through SPI or flash dump is 29.16%, and software methods and all is 20.83%, and other mechanisms, because different pen testers try different mechanisms, that is 12.5%. So this is the major reason for generally firmware extraction. So generally they suggest that UART has to be not exposed basically, it has to be disabled when in production. Yeah, so some of the software tools, and I'll not get into this. I'll share my presentation so that you can look into these tools which are available in the market. So the countermeasures, generally what people talk about is, generally your IoT devices should have firmware updates and patches so that any vulnerability is there, it will immediately have a fix basically. And generally you need to have multi-factor authentication so that it protects your system. And apart from that, whenever your data is in transit, that is, you are sending the data to your mobile apps, you're sending your data to the cloud, you need to use strong encryption and secure protocols like TLS, DTLS and all. Tamper resistance and tamper detection, whenever I try to open the box, immediately it should intimate the vendor. Or self-destroy, whenever I try to open, the firmware should automatically get destroyed. And the final component, easiest method, I would say that is disable UART and JTAG in production. So whenever you're doing a testing purpose, you can open them for debugging purpose and all. But whenever in production, this has to be disabled. So that is what I would say. The summary of my presentation is, we have talked about IoT attack surface, mapping the different components of IoT ecosystem. Then we talked about IoT pen testing, where we talked about the complete attack surface, the components of IoT and all. Then we took up 3 components, that is, I don't have a device, I can do with the help of the firmware, that is both static analysis and dynamic analysis. I can take up the tools available, which are available. I clearly told you that Binwalk, Firmwalker, Firmadyne, so many tools are there, FAT is there. And physical device, popular interfaces like UART, JTAG, SPI, I2C. If they're exposed, you can extract the firmware. And the tools available, as I clearly told you that there are a lot of tools available in the market, like JTAG later, Bus Pirate and all. If it's a connected device, yes, once it is connected, because you are over the network, you have various tools which can help you to do that, like a replay attacks and so. This is the summary of my talk. So this is how I complete my talk today. So I thank you all. Thanks for your patience. Only last statement I would say that don't think that a device is not hackable today. Basically, today there is always a way to hack a system, but only thing is it's just a matter of cost and time. That is the only reason a lot of complicated systems are not getting hacked basically, or not. I would say that any system in this world can get hacked. So only way we can do is we can more complex the system so that it enables the hacker to get into the system. Okay, that's what I complete my session. Thank you very much. One thing is, any questions are there? One thing what I'll do is let my colleagues finish the talk. Later we'll take up the questions. Okay, please, I'll give it to my colleague, Mr. Amal. So he'll be talking about the BLE exploitation. I will take up the questions at the end, sir. surely we'll take up all the questions. It's over to you, Amal. I think small inter. Okay. I think before giving it to my colleague, I think I just wanted to read out his profile for you guys to know what exactly he's doing. And so the thing is, Mr. Amalraj PC, I think he'll be talking about this BLE security fundamentals now. So we'll be taking up the topic on exploitation of radio communication protocols, especially targeting BLE. So Mr. Amalraj is currently working as a project engineer at CDAC Hyderabad. He holds BTech in Electrical and Electronic Engineering from Government Engineering College, Baton Hill, Trivandrum. He started working on embedded system design and testing since 2018 and working on IoT device security and pen testing for more than a year. That's a small introduction about him. It's over to you, Amalraj. You can start discussing on BLE security.
So, hi, good evening. Thank you, Sigan sir, for the introduction. And thank you, Sidak and SETS, for giving me this opportunity. So, today we are going to discuss about the fundamental aspect of the BLE security. And my agenda is today we are going to discuss about what is BLE, what are the attack methods, how we can implement security in a BLE device, and some of the some recommendation for my end users and for the developers. So we can start. What is BLE? So it is a shortcut for the Bluetooth Low Energy, also called Bluetooth Smart or Bluetooth 4.0. The BLE was introduced from the version 4.0 onwards, and I know that now IoT is everywhere. I'm pretty sure that you might have one of the IoT device, because there are a lot of IoT device throughout the market, like different wearables are there, sensors are there, light bulbs, medical devices and all. Why these much of devices are in the network, in the market? Because the BLE devices are very cheap, they are easy to develop, the power consumption is very less. Due to these reasons only, you are able to see lot of devices, BLE devices in the market. If you can operate the BLE device with a coin cell which can operate for a long duration of time, and the power consumption is very less, so that the BLE or your device can operate in a constrained environment also. So this is what the BLE means. You might be getting confused, because what is the difference between Bluetooth Low Energy and normal Bluetooth Classic? Actually, both are totally different. There is, because the stack for the Bluetooth Low Energy and the stack for the Bluetooth Classic, both are different. They have different architecture. They have different modulation parameters. They have, because in the case of Bluetooth Classic, there are 80 channels, but in the case of BLE devices, you can see there is only 40 channels, and the BLE hopping sequence is different from the Bluetooth Classic. So both are entirely different. BLE is a Bluetooth, but it is different from the actual Bluetooth Classic. It has different. It has a different protocol. It is a different protocol. Where is the risk? Actually, risk is everywhere, because I have tested a few devices. I have seen a lot of devices are not implementing. A lot of Bluetooth BLE devices are not implementing the BLE security properly. The device which I tested was smart lock or a padlock. In that, what is happening is I can see the traffic. I can capture the traffic, and with the help of a normal BLE scanner or BLE scanner app, I can connect to that application, and I was able to unlock that application by sending some commands. So there are a lot of BLE devices in market which are not implementing this security. One example is smart lock, which I have given. Second is smart watch or a fitness band, you can say. These fitness band and these smartwatch contain a lot of information about you. Okay, how your pattern, how your behavior, how your habit and all. An attacker can gather these information. These are known as identity tracking or privacy tracking. So he can get into your lifestyle and other details. Another example what I can give is insulin pump, which is used to in medical field. Nowadays, lot of BLE is used in the medical field also. Imagine that you have some insulin patch, and that insulin patch is controlled by your mobile application. Suppose if hacker get control of that insulin patch, yeah, that is going to be great. So next, what we are going to discuss is attack method. How an attacker can get into a BLE device, or how an attacker can attack your BLE device. There are three methods. This is an overall method. I am not going into each and every attack methods differently. I'm overall, from an overall perspective, I am saying. First one is passive eavesdropping. That is the BLE devices, the two BLE devices will be communicating. From an outside, I will be able to sniff the data. That is passive eavesdropping. So there are devices which are capable of sniffing these BLE packets. For example, the Elysis, the company Elysis have developed a high-end BLE sniffer, which is able to work for classic as well as for the BLE device. So it can sniff the data transmitted between the two BLE device. So, but it is pretty costly. It goes around $20,000. And Frontline is also developing such type of tools, which is very professional, where high-end sniffing is possible. But there are devices which is low cost, such as Ubertooth is one of the examples, and second one is NRF sniffer. You can get it at a $120 or something. It is available. The thing is, the high-end BLE sniffers are reliable, because if you are using a low-end sniffer, what I seen is, whenever I am using a low-end sniffers, there is a chance of missing the packets. With this Ubertooth and NRF, I'm not able to capture the whole packets, and also these won't work in the classic also. These Ubertooth and the NRF sniffers are specifically for the BLE application. So these are some of the tools which attacker can use for passive eavesdropping. And second type of attack is active attack. The example for active attack is man in the middle. The attacker directly try to target the BLE devices. There are tools. There are tools and applications which are doing these type of active attacks. And third type of attack is the privacy or identity tracking. Actually, in the case of smartwatch and all, I have explained that the attacker can scan the BLE device address, and he can form a trajectory. That means he will be able to understand the movement of the BLE device, and he will be able to understand from that he will be able to gather some information regarding the whereabouts or habits of the user. So such type of attack is known as privacy or identity tracking. These are the three types of attack methods which attacker will try to do. So next, we are going to explain about the architecture of the BLE. So actually, BLE consists of three components. One is the controller, second one is the host, and third is the application. So the controller is the lowest layer. The controller layer consists of the file layer and the link layer. This layer is taking care of the what I can say is channel hopping, radio control, linking, connection state. Everything is taken care by this controller. And the host, which is above the controller, provides the API for the application, or the which provides the API to control the controller. Okay, so the communication between the host and the controller is through a host control interface. This host control interface provides the communication between the controller and the host. So this is suppose the example for the controller is USB adapter. You can take USB adapter as an example for controller, and the host will be residing inside your system. So you are, in case you will be using different vendor USB adapter to your system. So this host control interface actually does what it is doing is it provides the communication between the controller and host. Whatever be the vendor, whatever be the vendor, this host control interface provides the communication irrespective of the vendor. Okay, so above the host layer, it is the application layer where your the mobile device will be connecting to the application, where the mobile application will be controlling your where your BLE device. And this is some of the basic information which I can give about the BLE architecture. I'm not going into the depth. Actually, in this talk, we are focusing on the security manager protocol, where our security of the BLE is implemented. We will be focusing on that area. Before going to the security manager, I will just explain the, actually, if you take any BLE stack or BLE, the what we can say is BLE does not have authentication or encryption by default. Actually, the BLE technology provides features to authenticate or encrypt the communication. Okay, so the BLE technology provides three basic security services. That is authentication, and first one is authentication and authorization, which is used to ensure the connection is established between the correct devices. Actually, this authentication and authorization is used to ensure that the connection is established between the correct devices, so that we can avoid the man in the middle attack. The second service is encryption. So once the data is transmitted between the devices, as I already told, there are sniffers which can sniff this information. If it is not encrypted, if the commands are not encrypted, or if the data is not encrypted, the attacker can see the data. And if the attacker understands the commands, he can directly connect to the BLE device through the tools like GAT tool and all. So if he send these commands, he can get control of that BLE device. So the encryption is basically to protect against the passive man in the middle attack. It is nothing but sniffing only. And the third one is third service is privacy and confidentiality. As I already told, it is to prevent the device tracking, because one of the attack is privacy and identity tracking only. So there should be some method to prevent this. That is BLE's technology is taking care of that also. And the BLE technology provides some 5 security feature also, like whenever you are connecting your device or your BLE device, smartwatch, or the smart lock with your mobile phone, some of the devices will be asking for a pairing process. But I have seen a lot of devices won't ask for the pairing process, because there are 80% or 70% of the device won't implement this BLE layer security itself. So but the BLE technology provides 5 security features. The first one is pairing. What is pairing? Pairing is the process of creating the shared key. That means there is a process. The pairing is the process which is used to create the shared key, so that this shared key can be used to encrypt the link. Okay, that is meant by pairing. And second is the bonding. So what the bonding does is it will store the key so that what happens is next time you don't need to pair. The BLE devices will use this stored key to form a secured connection. Next, the remaining 3 are device authentication, encryption, and message integrity. The BLE technology provides device authentication also, and encryption, as I already told. Message integrity is also provided to avoid the tampering of the data. So these are the 5 security features provided by the BLE. So our focus is basically on the, as I said, security manager. Security manager is a part in the BLE stack which is taking care of the security features. Like it is in charge of the pairing, it is in charge of bonding process, it is in charge of the key distribution, it is also in charge of what we can say, it is in charge of generating the different types of key depending upon the what type of pairing you are using. These all features, that means the whole security is controlled by this security manager. So security manager has AES 128-bit capability. So this layer of the stack is taking care of the whole security aspect of a BLE device. Okay. So here we are focusing on, our talk is basically on the Bluetooth version 4.0, 4.1 and 4.2. Basically, from a security standpoint, 4.0 and 4.1 are almost same, but there are some difference in the case of Bluetooth 4.0. There are 2 types of pairing in BLE version, that is legacy pairing and secure connection. The legacy pairing is implemented or supported in Bluetooth 4.0 and 4.1, and the secure connection is implemented, which is there is some the BLE Bluetooth group were able to understand that there is a vulnerability or there is a chance of attack with this type of pairing. So they, in the second version 4.2, they enhanced the security feature with a LE secure connection. Okay, that is in the secure connection they implemented more advanced security so that they can reduce the attack on the BLE device. So in the case of BLE version 4.0, 4.1 and all, it is a legacy pairing. Actually, the thing is the key exchange algorithm is insecure in this version. That is why what the BLE security people have done is they introduced Diffie-Hellman algorithm for the key exchange in the version 4.2. So they were able, with the introduction of this Diffie-Hellman into the BLE version 4.2, they were able to, the attacker will be, it is a bit difficult to crack this key or anything, because the Diffie-Hellman is a strong key exchange process itself. So next we are going to discuss about the pairing process. Actually, you might have seen this whenever you are connecting your smartwatch or the BLE device with your smartwatch. The first thing it will be, if the security is implemented, the first thing it will be asking is for the pairing. But yeah, as I already said, there are a lot of devices without pairing also. So the pairing is the main important process where the devices will be exchanging the keys, will be exchanging the features and all, so that they can form an encrypted link. In the case of pairing, it is a 3-phase process. The phase 1 is pairing feature exchange. What this pairing feature exchange mean is, whenever two BLE devices are getting connected, they will exchange their capabilities. The capabilities in the sense, what is capability means, you can see some of the devices will be having display. Some of the devices will not have display. Some of the devices will be only having keyboard. Some may not be having nothing, like a keyboard won't be there, display won't be there. Because these, based upon these features and their capabilities, they will be deciding what pairing method I have to use, whether I have to go for legacy pairing or whether I have to go for secure connection. In the first phase only, the master and the slave, or the initiator and the responder, will exchange their capabilities. Once they exchange their capabilities, then they will decide what pairing method they have to use. Okay, then they will initiate the pairing process. From in the second phase, then from the first phase, it will come moves to the second phase, which is basically a key generation process, where the key will be generated. So for the, in the case of legacy pairing, the short-term key is generated. For generating a short-term key, they are actually using a pin. Okay, they are actually using a pin or a temporary key, we can say. In the terms of Bluetooth, it is a temporary key. Okay, so with the help of this pin, this the legacy pairing or the key generation process will generate this short-term key, and this short-term key is used to encrypt the link. Once they encrypt the link, in the phase 3, the remaining keys will be set. That is, in the second phase, they will be generating short-term key, and they will use this short-term key to encrypt the link. And in the third phase, they will be sending the additional keys. The additional keys are like IRK for the, that is address resolution key. Sorry, identity resolution key, which is used for the identity tracking of the trusted devices. Or the BLE device might be sending the CSRK key, which is related to data signing. Or if these type of keys need, have to be, if these type of keys are to be sent, then what they will be doing is, first they will encrypt the link, then they will share this key between the devices. Okay, that is the phase 3. But in the case of LE secure connection, something is different, because it is not similar to legacy pairing. So as I already told, from the Bluetooth version 4.2 onwards, this secure connections come into picture. Here the key generated is long-term keys. Actually, for the generation of the long-term key also, we require a temporary key or a pin. And with this pin and with the algorithm, both the initiator and the responder will generate the long-term key. And again, with this long-term key, they will encrypt the link. And in the third phase, again, they will be sharing the other keys like IRK, CSRK, section key, EDVI, and all. One after encrypting this link by using the short-term key. So this is a brief explanation about the pairing process, which I can give. I hope you understood. So in between the talk, I was saying about the pin or the temporary key. So for the how to determine the temporary key, how to determine is while exchanging in the first phase itself, while exchanging the pairing capabilities and all, the devices will be choosing the what type of method or what type of method should I generate, should I take for generating the pin or temporary key. Actually, there are 4 methods for determining the pin. That is, first 3 are basically for the Bluetooth version 4.0 and 4.1. In the Bluetooth version 4.2 onwards, the Bluetooth group introduced one more method, which is numeric comparison. I will explain each one by each. First one is just work. It is, as the name implies, it is just work only, because the key or the pin is 0. So here, most of the devices are implementing just key type of method where each and every person's or each device I can connect. If this just work is implemented, right, what happens is I can easily connect to that device because there is no pairing or no pin for to connect to that device. So there are a lot of 60 to 70% of the device in the market are with this type of feature, just work. Okay, and it is I can hack such, we can hack such type of device very easily. It is not a big task. And second is passkey or entry, passkey entry, which is you might have seen in your car or somewhere. Whenever you are connecting your mobile to your audio system inside the car, in the display it will be generating a 6-digit number, and you have to enter that in your mobile application. Once you enter this once you enter this number into your mobile application, then the pairing process will proceed. If both the numbers are same, you can see that pairing has been successful. Again, since this is a 6-digit number, right, what are the probability or the possibility is from 0000 to 99999, that is just a 10 lakh. There are, again, it is possible to crack the key which is generated by this method, because possibly there are tools and there are things which we can do to crack this pin. Okay, again, this is not a good method. The third one is out of band. Actually, till now I didn't see any devices with this out of band, because uh, I don't know why, because till now I didn't find any device with this out of band feature or out of band method in their device or anything. But the BLE is in the BLE documents, they are specifically saying about this feature or this method of pairing, which is out of band. So here what is happening is the key or the secret key is not transmitted over this 2.0 gigahertz band, where the this Bluetooth is working on the spectrum of 2.4 gigahertz, but the key is not shared between this between this 2.4 gigahertz. Okay, though for then the method for exchanging the keys are NFC or QR code, which is NFC is near field communication and all. Till now I didn't have any devices, or I didn't try this feature also. And the last one is numeric comparison. This is only in the Bluetooth version 4.2 and above, and which is implemented in LE secure connection. Here, what happens is both the devices will be displaying the same number. You might have seen this. I have seen a lot of MI watches, OnePlus watches, which is implementing this numeric comparison, where whenever I am connecting this my mobile application to the smartwatch or smart band, they will be, both the devices will be displaying a 6-digit number. Whenever I acknowledge both the device, then the pairing gets started, and if both the displayed numbers are same, then behind a lot of other activities are happening. Then if both the numbers are same, then the pairing will successfully get pairing will be successful, and your mobile application will be connected to the your BLE device. These are the 4 methods to determine the pin or temporary key. So next is, so is it secure or not? The thing is, there are a lot of BLE devices which are not implementing the BLE security properly. Most of the device, what I have seen is they are trying to implement the security in the application layer. That means they will be just encrypting or converting the data to hex or some other format, and they will be sending the data to between the devices. So what happens is, if an attacker is able to sniff the data, he can see your information, or he will be able to get into the control of the commands. Once he understands the commands, there are a lot of tools, there are a lot of really application itself, like NRF Connect and all. By using that application, I just need to pass these commands to get control of that devices. So applying the security at the application layer is not a good practice. We have to use the BLE link layer encryption, so that no one can get into the BLE layer, or no one can steal the data which is transmitted between the BLE devices. So I have few recommendations for the users as well as for the developers. So whenever you are purchasing any BLE devices, try to purchase from the official channel so that you can trust. And second thing is, before purchasing, you should make sure that you should read if there is any content regarding the BLE information, security information or not. If you are directly going to the shop and if you are trying to purchase, then first switch on the device and see what type of pairing is happening, whether pairing is there or not, so that you can understand what security is implemented in that device. So third thing is, whenever you are not using your smartwatch or the BLE devices, just turn off the Bluetooth. So what happens is the attacker won't be able to connect to your device. Attacker won't be able to connect to the device. And the third, because most of the time what happens is your phone might not be connected to a BLE device, but BLE of the Bluetooth will be on, so the attacker can get connected to your BLE devices. And the last, then what other method is update the firmware. If any update is asking if a device update is there, just update the firmware. The developers, what recommendation I'm trying to do is they should understand this BLE layer security, and they should try to implement the stack layer security of the BLE so that they can limit the number of attacks and timely update the patches or firmware with if any vulnerabilities are in your detected. Okay, that is it. Thank you.
Yeah, thank you, Amal, for the nice presentation on BLE exploitation. So we'll continue with the presentation of Mr. Mirza, because we'll talk about Wi-Fi and then we'll take up questions for all the 3 sessions. Okay. So the thing is, let me introduce Mirza. Just a minute. So Mr. Mirza, I think he'll be talking on the Wi-Fi security. So the thing is, Mirza is currently working as Quality Engineer at CDAC Hyderabad. He holds BTech in Electronics and Communication Engineering and a PD Diploma in Embedded System Design. And he started working on embedded device since 2018 and working on pen testing of the IoT device for more than a year in the CDAC Hyderabad. So Mirza, it's all over to you. I think we'll listen from you regarding Wi-Fi security for IoT. Yeah.
Thank you so much, Srikanth, for my introduction. Before starting, I would like to show my gratitude for CDAC Hyderabad and SET Chennai for giving me such an opportunity to put my views on Wi-Fi security. So in this, I will try to put some light on importance of Wi-Fi security for IoT devices. So I will be covering some importance of Wi-Fi security and what are some recommendations to secure Wi-Fi environment for IoT, and what are the Wi-Fi authentication and encryption protocols, and what are the levels of those. And then I will be finishing off with the conclusion and some recommendations. So to start with, the why we use and Wi-Fi security and why it is so important in wireless Internet of Devices thing. So while the reason we use Wi-Fi security is that it is highly used in almost all of the areas, and you can easily find in the houses. And also IoT devices have one requirement, that is they should have a wireless technology so that they could be easily and flexibly used. So because of which and easy implementation of Wi-Fi and most popularity of wireless networking, the Wi-Fi is being used in IoT devices. It also has a very fast transmission rate, which actually goes around 600 megabits per second, and it is easy to deploy, and there is no extra gateways are needed if you use a Wi-Fi on IoT devices. So because most of the households already have a routers and Wi-Fi used in them. So the next is most of the networking requirements of IoT devices has actually met by Wi-Fi technology, because of which it is also been used, and almost all of the IoT devices most popular, such as Wi-Fi routers, network cameras, smartphone appliances, are very commonly used Wi-Fi. And the use of Wi-Fi technology also enables mobile phone and computer applications to control and monitor the IoT devices. So this is a diagram which actually shows. One second. Yeah. So this actually shows an infrastructure of how IoT devices can be connected through Wi-Fi. Before starting, I would like to tell, if we are about to use a IoT device which with an Wi-Fi enable, what are the things that we need to take care of? Since we have many devices that have been connected to Wi-Fi, such as computers, mobile phones, where we do daily transactions about money and all. So it is always recommended to isolate the IoT devices network to isolate the IoT devices network from that of a network which was used by computers and mobile phone. So that in the worst case scenario, if an IoT device is being hacked or by an attacker, then even though they cannot get into your mobile network or into your mobile phone or computers where actual important information is stored. This can be done with DDWRT firmware, which is actually a custom firmware. This can be installed on our routers, or else a Cisco equipments actually have inbuilt feature of isolating a network within a network. So another thing is device updates are very important part, because the most of the time in every scenario, whether it is any device, not just IoT, the purpose of device updates are basically to upgrade the features and to patch the vulnerabilities or weaknesses that has been found. So that's the reason it is always recommended to keep on checking the patches and install the patches in a timely manner if there are any available. And the next is to have the control over who can configure the Wi-Fi network and connect to the Wi-Fi network. So this is also plays an important role, since unauthorized devices should not be connected to a Wi-Fi network, or else they could exploit a whole home network itself. And the other thing is securing the data. So since the Wi-Fi network is, we are saying we have been using Wi-Fi network, so that the network actually uses some transactions, data transmissions, and these transmissions should be traveling very securely so that unauthorized cannot view the data. So for above points to implement, we need to have an broad knowledge of what are the Wi-Fi authentication processes and encryption protocols. So first of all, the Wi-Fi, the first one I would like to highlight is Wi-Fi Open Network. So Open Network is nothing but it will only show you an Wi-Fi network available, and the moment you tap on it, it will connect to the network. This does not even have an encryption or anything, and it is highly insecure. To secure the Wi-Fi transactions, the first security feature that has been implemented for Wi-Fi is wired equivalent privacy. This wired equivalent privacy uses is been started certification in 1997, and it is actually an early day solution for wireless technology, and its actual main goal was to prevent the man in the middle attacks. The traffic here is been encrypted by using a 64 or 128-bit keys, and these keys are being transmitted in hexadecimal format. And the main weakness of wired equivalent privacy is that it uses a single static key for all the transactions. Not only just that, it also uses the same static key for different devices as well. Because of which, at that time when this was implemented, it did serve the purpose, but with the high increase in computation power and all, this nowadays can be easily cracked within 5 minutes. And there are also many automated tools that actually help you crack WEP without much knowledge about it. So later in 2004, IEEE itself declared this WEP as an insecure Wi-Fi protocol, and came up with the WPA Wi-Fi App Protected Access Protocol. This actually uses TKIP, which is actually has 64 to 128 bits of encryption keys, and these keys are manually entered. These are still not as does not use much strong keys, and this also includes message integrity check algorithms. Even in WEP, they use message integration check algorithm, but uses a CRC for that integrity, which is not that reliable. And TKIP is much more reliable for message integrity check. And with over the time, this also been exploited. And since the main purpose of WPA is it has been implemented on a devices that already used for WEP. So for further, there was limitations of hardware, which was overcome when we came up with WPA2 protocol. This actually requires a new hardware to be purchased, and it does not work on the older devices that was came up with WEP or WPA. And this was highly adopted in 2004, and new devices only supported this instead of old devices. So this has two types of encryption mechanisms, TKIP and AES. So since TKIP, as told, it uses a very weak keys, and instead of that, AES is being used, where AES is believed to be a very highly secured encryption algorithm, which was actually being used by US government for securing the state confidential information as well. With the over the time, this WPA2 as well get hacked, and there are some previous vulnerabilities which are such as crack key reinstallation attacks, where the attacker uses some rogue access points and force the target to connect to rogue access points and allow receive the enough packets where it can do the brute force to get the encryption keys. And once the attacker gets the encryption keys, they can easily decrypt the whole traffic that has been transmitted over Wi-Fi network. And to capture the Wi-Fi network, it is pretty simple. All the attacker need to do is to buy a Wi-Fi receiver, and then he can simply put that Wi-Fi receiver in a monitoring mode and capture the packets, even though if it is not connected. So that's the reason. And with these previous vulnerabilities uh, and the weak passwords also, the WPA2 does not restrict a user to force a complex passwords, and it uses 8 letters of password. Uh, and WPS is also a feature of WPA2, but this feature is very implemented for the simple authentication steps. Instead of connecting with an complex steps, WPS is implemented so that direct connection between two devices can happen. This is not secure, and it uses a pin code for pairing for connection, and this pin code is of limited numbers and can be easily hacked. So it is always recommended to disable the WPS or use only when necessary. So the later part in 2018, the certification of WPA3 has came into picture, where the WPA3 uses 192-bit key, and it is believed to be highly secure, and it is the latest security protocol that has been implemented for Wi-Fi technology. So WPA3 has two types. WPA3 SAE, which is basically implemented for normal and uses for households. And this SAE, which means simultaneous authentication of equals, uses 192-bit key, and it does not allow the decrypt of the encryption key with just even if the password is leaked. So it actually creates multiple parameters, use multiple parameters to create an encryption key, which cannot be decrypted even if an attacker gets to know the password. And WPA3 ENT is specially invented for enterprises, where it uses MFP, which means Management Frame Protection. This MFP allows protection against brute force and also detect then rogue APs. Rogue APs is nothing but just an malicious access point with the same name as our actual access point, which and with that malicious access point has the same SSID. Some of the target devices may fall into the trap and connect to those malicious access points. So this is brief about the encryption protocols of Wi-Fi security, and what are the security levels of those. So as you can see here, open Wi-Fi network are very insecure. Does not have authentication and encryption mechanism, and the possibility of data leakage and being attacked is very high, which is why it is not recommended. WEP, and again because of it's been implemented at a long time ago, it is insecure, and there are many ways of getting into it, and password can be easily cracked, and it is also not recommended. WPA2, WPA, TKIP. WPA2 using TKIP is also assumed to be insecure because the keys that has been used for TKIP are very weak, and through a packet on decryption is easy, and the packets on network can be inject arbitrary data into a wireless network. And WPA2 AES. Using an AES is also a risky since it is vulnerable to brute force cracking, and there are past vulnerability that has been found in WPA2 AES, such as crack, which I have already told. So because of which possibility of data leakage is high here. Even though it is recommended just because the WPA3 is not yet adopted entirely, and if we are using WPA2, then it is necessary to update the patches and fix the past vulnerabilities. And another important point is to have a strong password that could protect the device from the brute force attack. So then the WPA3, which is assumed to be a secure, and it also fixes the previous vulnerability that has been found in the previous security protocols, and it cannot be cracked by the brute force. It is highly recommended, but since it is still in early phase, if it is an availability, it has to be used. Otherwise, we can go with the WPA2 AES encryption with a strong password. So this is an example of how an WPA2 and Wi-Fi network can be easily cracked. As you can see here, there are some tools such as AeroDump here. In this example, I'll be showing here with the command AeroDump ng and with the Wi-Fi receiver in a monitoring mode, we can see the possible access points and the clients connected to them. As we can see here, our target is TP-Link F3FC. So once we get the MAC address of the target, we can easily deauth the users from that access point. Deauth is nothing but we will forcefully send some packet to the clients that are connected to this TP link, where that packet actually says to disconnect the device from the router. So continually sending them will disconnect the device from the router. Once we disconnect the device, we can just capture the packets with that specific MAC address, and the hag one here is a file that we're gonna save the captured files. And once this is been captured, we can see here WPA handshake appears the moment when we capture a successful handshake. So the connection between a client and a router happens through a four-way handshake. If this four-way handshake is being captured by an attacker, there is a possibility that he can easily decrypt the password. And this four-way handshake can be displayed in Wireshark as shown in the last picture as a protocol EAPOL. So once he can capture the four-way handshake, he can use the brute force attack to decrypt the password. Here we are using a rocku.txt file, which is actually a text file having a many texts that has been found over the internet, has been found by the data breaches and everything, and it consists of many passwords. So if the attacker is lucky and your password is weak enough, they can easily crack your password, as here it has been done in 37 minutes, less than that we are able to capture the password, which was very simple, that is hello hello. So yes, apart from that, what about the weaknesses in Wi-Fi IoT devices? The earlier we were talking about the Wi-Fi architecture infrastructure of IoT devices, but what if a device has enabled Wi-Fi with it? So the main possibilities of weaknesses that we have been found in our testing, in the day-to-day testing, is that the IoT devices have very weak port management, which means they use very less secure ports, and they leave open unused or vulnerable ports, and they do not even patch even if it is vulnerable. So the other thing is transmission without encryption. Uh, the IoT devices, suppose consider a scenario where an attacker got into your home network. If then he can see the traffic of a device. So it is always recommended that we should buy a device that implements a TLS or SSL encryption transmission, which actually encrypts the data even if under the Wi-Fi network, which act as a extra layer of security, such that even if the attacker get into a network, he cannot decrypt the packets or anything. And weak authentication is another very common vulnerability we have been found in the IoT devices. They does not force a user to use a complex passwords. They does not use a two-factor authentication, and most of the time they come up with a default username password, which can be easily guessed or could be easily found in an internet. And access control is another authentication feature that allows multiple users to change configuration and normal users to only monitor a limited set of functions. So with this, I would like to tell you that there are some important points that we need to put in mind when we are about to use an IoT device. So always avoid default passwords. Use a large number of bits or complex passwords with upper or lower case characters, numericals, and special characters. This will help you avoid to being a target of a brute force attack. And also set the recommended level of security as applicable on the device. Some of the devices comes with a default low security features, even though they are capable of implementing high security, such as WPA3, WPA2 that we have to take care of, and that WPS should be always turned off, or even use the devices that implements the WPS buttons. When we use the WPS buttons, it will connect to the WPS only when that button is pressed, and after the timeout or a being successful connection, it will turn itself off. So another main important aspect is to update the device firmware with security patches to fix vulnerability. So this, as explained earlier, it is very necessary to keep on checking the updates and install those updates to fix the vulnerabilities, and separate the network of IoT devices from that used by computers and mobile phones. And since if we implement this is actually a hard to implement step, but if we implement this, it is actually very secure feature that we can say. And beware of the security alerts from the device. Do not ignore the security alerts from the device. So, yeah. Do not ignore the security alerts from the device and take a proper action. So with this, I hope also one more point is unnecessary ports should be always closed. So I hope I have shown some important points about the Wi-Fi security. Thank you so much.
Yeah, thank you all. I think we are open to questions now. Any questions from your side? Yeah, I think can we get all the present? Yes, I will be. I think. Which tool can use VLSI implementation of energy efficient and secure near sensor analytics at an IoT endpoint? Question is not clear. Question is not clear basically. So yeah, please explain. Pinot reversing is these are because generally you have UART and JTAG and all these things. So just looking at the pins and all those things, generally the pinots, if you look at as you have seen, there can be a data pin. There can be, like, if you look at MISO-MOSI and all in the SPI and all. Just once you get hold of those pins, you will be able to connect it with the tools and push the data from the tools basically. So that you can get the access of the firmware or extract the firmware from them. So that is generally what we do once we find out the pins from for these interfaces. Any other questions? Yeah, slides and all will be shared. This is not our question. So I think no more questions. So no more questions. Then we'll move to the next speaker. Okay, I'll stop sharing. Stop sharing. We'll move to the next speaker. So please, Mr. Hari Prasad. Hari Prasad, are you there?
Yes, sir, I am there.
You're there. Wish to give access? Sets 1, sets 10,
That's Chennai, sir.
sets 10.
Yes.
So I'm giving the role as presenter. Yeah. You'll be able to share the presentation. You are able to share. Yeah. Please share it. I think. Okay, guys. I think we'll move to this session by Mr. Hari Prasad. He's a scientist at SETS. So he'll be talking on drone as security target and threat. So let me read out his profile for you guys, for your reference. So Mr. Hari Prasad R is working as scientist at SETS Chennai. He obtained BTech in Electronics and Communication from Calicut University, MTech in VLSI, and Embedded System from QSAT, and MBA in Marketing from Pondicherry University. After a year of internship at Hardware Design Group at CIRAC Trivandrum, he worked in R&D department of ITL Limited Bangalore as assistant executive engineer for 4 years. Then he moved to 5G and data center group at VVDN Technologies at Cochin, a senior FPGA engineer. Currently, he is working in the hardware security research group at SETS Chennai as scientist for the past 2 years. His experience includes cryptographic module implementations in FPGA, 1G, 10G, TCP/IP security, and implementation of error correcting codes in FPGA for 5G. His research topic includes cryptography, IoT security, and secure drone design. All the way to you, Mr. Hari Prasad. You can start presenting.
Thank you, sir. So, since already one speaker has told about drone security, so I'll be trying to cover which he has not covered to avoid the overlap. So, briefly I will introduce about drones. I think already the earlier speaker has done, but still I will go through it. Then basically I will tell how means the UAS means the unmanned aerial system. So how it can be, how UAS can be a target to cyber attacks, and third point is how UAS can be a threat to us and what will be the countermeasures to that. So in India, basically there are 5 classification of drones. So this classification is done for commercially available drone, and defense drone won't come into this classification. And there are different types of classification patterns are there across the globe, but in India it's just based on the weight, like whether it is less than 250 gram or more than 150 kilogram. So these are the basic 5 classifications. And there are different levels of autonomy also for UAVs. Like in level 0, there won't be any automation. The drone will be 100% under the control of the pilot, who is or which is there in the ground control station. And level 5 will be having a full automation with AI capabilities. So it can learn and based on the earlier flights, and it will be knowing what to do if any problem arises. So based on the involvement of a pilot, the autonomy can be classified to these 6 categories. And of course, there are various applications of drones are available. Many of us know it's used in agriculture. It can be used for monitoring in the critical infrastructures. It can be used for drone light shows. It is used in insurance sector as well as disaster management purposes. So like that, many applications are there to be there. So I'm not covering this much. So this is one important thing because drones are basically news from the where we are seeing in defense purposes, or we are seeing some drones are coming into our borders and it was shot down. So basically we are hearing more in the news about this 2% only. But basically, according to many forecasts, drones are going to be used more for industrial inspections, where manual inspection is nearly impossible or it is very difficult. And it can be used for aerial photography, real estate. Then comes agriculture in 19%. Then comes insurance sector, means it will be taking risk assessment, claims adjusting, like basically if some calamity or something happened, like an earthquake happened, I am going to claim that my house is fully damaged. But how to ensure how much damage has happened? So basically insurance companies are also using this drones for verifying the claims and maybe a damage determination also in live, like some like flood comes. So it will be helpful in doing disaster management also. So this functional modules also, I think the earliest Vivek Mishra in morning session, he briefly told about these 4 modules. Since his slide was not available, I will just explain like there will be like 4 basic components will be there. One will be for data collection, like some sensors will be attached. It may be a video, can be temperature, or it can be anything, any sensors. Next will be like communication, which is very important part, where it will be communicating with the ground control station, and it may be communicating with the GPS also. So as he told, GPS may not be available for all commercial drones, but there are certain scenarios where GPS applications are required, especially if it is fully autonomous, means there will be no pilot on the ground. So it will be under fully autonomous. It will be getting the location from GPS only. So at that condition, GPS will be there. And obviously, navigation and flight control is a must for any UAV. So in the navigation, again, autopilot or manual control, which will be based on the level of autonomy which I explained. So manual control, if it is purely level 0, means only manual will be there. There will not be any autopilot. And if it is fully autonomous or in between level 0 to level 5, this autopilot, this component will be varying. This capability of autopilot will be varying. And based on the input from sensors, navigation and GPS, this flight control module will be operating. Means to control the motors, to control the speed, everything will be done by this component of the UAV. So this slide will explain that the middle part, like 85% of the literature available says how UAS is a target to cyber attacks. And only some 15%, as of now, only 15% of cases are reported where UAS can be used as a weapon, or it can be used, or it can be used as a weapon to attack any. It can be a cyber attack or can be a physical attack also. So based on these things, basically denial of service and spoofing will make around 3/4 of all the attacks available. And other attacks will be very less compared to these 2 things. And attack surface also, Wi-Fi network, it may be the communication between the ground control station and the UAV, and the drone remote control system, that also will be one part of the attack surface. And GPS of the drone, that GPS communication link also will be an attack surface. Data transmission is comparatively less compared to the other 3 attacks. So coming to the attacks on drones, so we'll see a scenario here. Here GCS means ground control station. So this will be basically sending the control signals to the UAV, and this will be receiving the sensor data also. And it may be connected to a satellite for precision, location and time. Now let us see where an attacks can come into this scenario. There can be one scenario is like malware induction in the UAV or in the ground control station. And with or without a malware, an attacker on the ground can jam or spoof GCS signals, or it can jam or spoof GPS signals, and it can basically jam UAV and GCS signal also. So any possible jamming or spoofing, both are possible. It can basically spoof sensor signals. Basically, if malware is present in the UAV, means all the data, sensors data can be routed to the attacker. And it can perform denial of service also. And there is one more possible scenario that an adversarial UAV can come into the picture, and basically the whatever attacks can be done from the ground. There will be some limitation of an attacker sitting on the ground to attack a flying drone, because there are some limitations, like if we have to do some GPS spoofing and all, means there are some limitations to be done from the ground level. So some attackers can send their UAV to attack and take control of our legitimate UAV also. So let us see cybersecurity threat model of UAV. So basically, these three are the basic aspects of cybersecurity: confidentiality, integrity, and availability. So let us see each case one by one. In confidentiality, the attack can be on the ground control station, it can be on the UAV, it can be on the communication link, or it can be from human side also. So malware and Trojan injection on the firmware or on the hardware can come both on ground control station and as well as in the UAV side. On the communication link side, eavesdropping, spoofing, and protocol-based attacks will come into picture. So I'm not going deep into eavesdropping and spoofing and protocol-based attack. Protocol-based means it can be Wi-Fi or BLE as explained by the previous speakers. So if this protocol implementation is not done with proper security and all, this kind of attacks can come into the picture. And human means by threatening or social engineering the pilot or people in the ground control station, these attacks can come. And integrity level, it can be unintended or it can be malicious also. So unintended means it can be due to some lightning, solar flares, which are very rare, but it can create, even it can disrupt the satellite also. So in such kind of natural scenario, this integrity can be compromised. In the case of malicious, it can be due to by capturing the packet, modifying and retransmitting can be one case. It could be by jamming and retransmitting the signal. And signal integrity can be broken with the distortion and affected signal to noise ratio. Means I am constantly sending more high power noise signal so that the integrity of the actual signal will be lost. And availability also, one can be unintended like natural causes and malicious also. So in the malicious thing, again jamming can come, denial of service can come, and modifying of the control signal. So modifying control signal means it's the control signal going from ground control station to the UAV. And denial of service like buffer or overflow, flooding and spoofing. So I'm not going into depth of each one because already this kind of attacks have been explained by previous people. Flooding can be by pumping more number of UDP and ping packets. So I think GPS is the only one thing which has not been covered till now, I think. So I will explain a little bit about GPS spoofing. So this we can see it as a initial location of the drone, which is actually going through its prescribed path, where it is getting the location information from the satellite. And if there is an attacker on the ground, and which is sending some spoofed GPS signals. So this is the black thing is the actual intended path of the drone, but using this spoofing attack, the drone can be landed to some other destination. So it maybe it can be made for a free fall, or it can be made to land in the attacker's friendly area. It can be in any case. It's not that it can be spoofed to a destination alone. It can be made to fall freely also. And these three are the methods for GPS spoofing attacks. One method is like replaying of the original signal, but it may be replaying of original signal itself at various point of time will also be a issue. Fabrication means transmitting fabricated signal. So GPS signal will be captured, then it may be fabricated and transmitted. So it may not be a valid GPS signal. And time alteration is like GPS is basically used for location and timestamp. So the timestamp of the GPS signal is a very important factor for that for the variability. So changing the timestamp will also create an issue for the UAV. So what will be the countermeasures for securing the UAV? So as my previous speaker has told, we have to use latest security features of wireless protocols. If it is Wi-Fi, means that WPA3 is the latest version. So try to use latest version of wireless protocols and all the security measures of that wireless protocols must be implemented. And there should be proper intrusion detection and prevention system, like using signature and public key exchange in the data links. Then there should be proper hashing mechanism should be there for authenticity, and encryption mechanism should be in place for confidentiality. So I'm not going into the, basically I think currently AES will be the encryption algorithm mostly widely used in the UAVs, but there are many attacks for that also. So that is the basic point in that one. So however, it should not be left without any encryption methods. So that is a basic point. And if possible, we have to use redundant communication channel also. Means even if one communication channel is attacked, we can work with the redundant communication channel. Definitely it is going to increase the cost, but for highly secure purposes, this is a recommended method. Then these are some of the recommendations made by some certification process is going to happen in India. So I've taken some of the points from them. So one point is like we have to alert a remote pilot if there is any loss of command and control data link. Means if the UAV, if there should be some mechanism for the UAV to detect if there is any loss of command or control data. If that should happen, it should be immediately reporting back to the ground, so that the autonomous feature can be taken over by a manual pilot and we can do the remaining things. And there should be some return to home functionality should be there. If there is any data link lost or any control, any means any issue comes in the data link, especially the control session, there should be some return to home functionality instead of drone getting like the GPS spoofing means it will go and land in somewhere else where it will be a friendly area of the attacker. So to avoid such things, if any attacks comes, there should be some return to home functionality. So return to home functionality means there should be some pre-programmed path, so that if any attack comes, it should go and deviate and come back home. Something similar to that. And coming to firmware and hardware, how to be secure. So secure boot, already speakers have told about same feature, like root of trust mechanism, secure booting should be there, and firmware tamper detection and avoidance mechanism should be there. And like post feature, power on self test feature should be there. Like if if the drone is getting powered on, if all the checksums and of the firmware should be calculated first, and if it is a valid checksum comes, then only it should actually fly. Basically, it should not fly if there is a checksum failure. And same method can be used for an update also. Means if the firmware is getting updated, it should be with the signature of the US manufacturer, and the new hash value should also be stored in the system, so that during the next post, same hash value can be, or the checksum can be verified again. And similarly, there should be tamper detection mechanism for hardware also, and for each onboard components. So onboard components means it will be like GPS location, GPS, it can be many sensors which are very critical to the system. So I'm not going into deep of everything. And GPS also. So how to secure GPS communication? So one method is like basically if a UAV is flying, it will be having the link with multiple satellites, at least a minimum 4 satellites it will be there. So that relative power of that relative power of the GPS signal from the satellite, since satellite is very far away, that relative power of that GPS signal will not be varying that. But if an attacker is spoofing from the ground, there will be a lot of power difference will be there. So if we can identify that power difference, this can be detected. This spoofing attack can be detected. And there is another method of angle of arrival, like the angle of arrival of that GPS signal from the satellite and from the ground also will be different. So based on that also we can detect a GPS spoofing. Next will be like use of multiple GNSS receivers. So it's not only GPS signal is available. There are Navic is there, which is a navigation with Indian constellation. Instead, it is the basic GPS from India and GLONASS. So there are multiple GNSS implementations are there. So if we can use parallelly use GPS, GLONASS, and Navic kind of thing, if this kind of attacks are detected in GPS, we can switch to other navigation system. And there are also some proposals like AI-based GPS intrusion detection mechanisms are also proposed in one of the papers, where like parameters like the satellite number, signal to noise ratio, range, Doppler shift, etc. Those kind of parameters can be given, and it can be used to learn, and which can be used to detect any GPS attacks coming into the picture. Now let us see the attacks done by UAS. So there are many UAV malpractices. One will be like spying, which we are basically seeing nowadays. Spying in the borders, spying on critical infrastructures can be a threat to personal privacy also. Next will be like cyber attacks done by the UAV. It can be an attack on a legitimate UAV, which I have shown in the case which I have shown in the previous slide. And it can be used to detect and intrude in a Wi-Fi network or GSM network. So there are some case was reported some 3-4 years back, like a state-controlled drone, which can basically come over some few kilometers above the ground, and basically not kilometers above the ground, but it can come over an area, and it can basically connect to all the mobile phones to that drone. So the phones will feel that this drone is the actual mobile tower, and all the communication can be basically attacked using that drone. And it can be used for disruption by pollution, like in airport, in airport, like even if a bird comes and hits a aircraft, there will be a huge disaster. So basically, if drones are coming and actually hitting, it will be a big disaster. And during disaster management, also drone can be okay. Drone is used for disaster management purpose, but it can be used for disrupting the process also. Yes, and of course, terrorist activities we know it can be used as jammers. It can be used to fire explosive, and for smuggling of weapons and drugs. So smuggling of weapons and drugs also we are daily hearing about this kind of cases. And in defense, the first case buddy lasing means a laser point can be made from a flying drone, which this laser point can be used for a laser guided missile coming from behind the aircraft, or it can be based to spot an artillery behind a big mountain, or it can be used as a communication relay also. So this is a good application, but if it is with our enemy, this is a kind of an attack from the drones. And this is one case made by Synistic Technology. This is an Austrian-based company which is giving the service to NATO. And this can be how it means a drone can fly. This is a fully autonomous drone where it is having a planned mission which will fly over some zones, and when it is above a zone which is like 1 kilometer away from the ground, and which can even jam all the RF signals which is 10 kilometer in diameter. So this is such a typical case where a drone can be used for electronic warfare. So it will block all the signal from 20 megahertz to 6 gigahertz in this 10 kilometer range. And there are some counter US methodologies also in picture. Many methodologies are there. So this is like basically this picture is from a defense point of view. Like first will be like deterrence. We should not think of using a drone to attack us. That is deterrence. Suppression means also similar to that only. Avoidance means okay, they plan to do some attack, but how we can avoid it. Next will be like detection. Okay, there is a drone attack coming into picture. How to detect it first, how to identify, how to localize that drone, and how to give response. Response can be a neutralization also, or it can be some decision making to avoid some security problems. So this techniques first is like monitoring. So we can use radar, like how we can use the radar to detect an aircraft coming into picture. So similarly, we can use the radar to detect a drone also. It can be used for long range. It will give good accuracy, and it can be used to track multiple UAVs. But the problem is that UAVs are not that big as an aircraft. Okay, big UAVs can be tracked using a radar, but mostly the UAVs will be very small. So it will not be a good method if UAVs are very small. And it's very difficult to distinguish birds and drones. Expensive also. RF analyzers is another method, like there will be some communication happening between the ground control station and the UAV with some RF signals. So if we can detect that RF signals to detect the presence of UAV, which will be a low cost method, and there will be no need of licensing and all. But it can't be used to detect autonomous UAVs because autonomous UAVs will be having very minimal contact with the ground control station. So RF analyzer will not be applicable in that case, that kind of scenario, and will be very less effective in RF noisy environment. If we are analyzing an RF, if the environment itself is noisy with RF, will not be useful. Then next will be like video and audio surveillance, which will be okay. Some short range directional methods can be used, but it will not be that much accurate. It will depend on highly about the it will be highly depending on the environment. Audio surveillance means it can't be means audio surveillance. How it comes to picture means like there will be some, if it is a big drone, there will be sound from the drone motors and all will be coming. So how to detect that? So if the environment is again noisy, it will not be effective. And there could be some false positives also. And how could be the response? So response, like first method is jamming. So jamming is like there can be 4 methods of jamming. Noise is like adding noise into that frequency. So we'll be using high power RF generators to create noise in the frequency of operation of that particular protocol. But it can be mitigated easily also. And tone is another kind of thing where we will be giving some small part of the frequency only. We will be giving this, so maybe in some certain channels of the protocol only we will be giving this jamming. Since we can give only in some certain channels, it will be not effective in the frequency hopping method. Means frequency hopping means if like as he told about Wi-Fi, some 40 channels are there in Wi-Fi means some it will be hopping from one channel to another channel. So if that kind of implementation is there, means tone method won't be that much effective. Follower means even though this channel is changing, it will be following that channel and creating jamming into all the channels. So it will be effective in this case. But of course, more resources are required. Smart jamming is like, okay, we know that a drone is coming which is using Wi-Fi, like Wi-Fi 4 only it is using. So if we know, if we have some prior knowledge about the drone and whatever and all the RF related methods are known to us before, then we can use the smart jamming techniques. So it will be power efficient and reliable, but it will require some transmitter like a software defined radio kind of a hardware will be required to do such things. And of course, other things will be like spoofing sensors and GPS signals. There could be some physical response like using nets, can be projectile like missiles, and high power microwave and high energy laser beams can be used to basically create issues in the hardware of the or the chip present in the UAV also. So such kind of response also can be given. And other methods is like it will be very rare. It will be very difficult from an attacker point of view to induce malware and trojans in the enemy's UAVs. And so the challenges in counter UAS technologies are like detection effectiveness will be low if the drones are very small or if it is flying just above the ground. Or if we are using like RF attacks, we are trying to do means if it is an urban environment and all many RF signals are already there. So if you are trying to attack the drone, it will be attacking everything. Means it will be creating an RF disruption everywhere. It will be like an electronic warfare. we are doing in our own place. So this kind of limitations are there. We should know the exact frequency, which frequency band that UX is communicating. And there could be some false positives and negatives. So that is very difficult to achieve. And how to distinguish a UAV, whether it is a legitimate one or a illegitimate one. We should not be firing or doing some attack to our friendly drone. How to identify which is a friendly one and which is an enemy drone. And response window. So if a drone comes for an attack, how to respond in very quickly manner, maybe in nanoseconds or microseconds, we have to detect and do the response. So the response window will be very less. And legality of counter UAS methods. So some methods like RF or high energy laser beams and all may not be legally applicable. So that should be known. Of course, these methods are very expensive. Maybe basically used by defense and only. So by concluding, so the security challenges and countermeasures are highly dependent on the type of the drone which we are using and depending on the payload of the drone. We are trying to attack a drone which is having some explosive and trying and making it for a free fall in our place means again it will be a problem. So it will basically depending on the payload and what kind of drone it is coming. So we have to so the countermeasures and security challenge also will be different for different types of drones. It will not be a simple. There will not be a single solution for all types of drones. And next point is like since the morning speaker also has told, like there is no proper standardization or uniqueness is not there for all the manufacturer point of sight or user point of view. We don't have a how everyone is implementing and security features, whether it is there or not, how to identify a friendly drone or not. So there are a lot of issues are there related to drone security. So government is coming with some laws and some rules are coming into the picture where each drone in the nation should be registered and pilot license should be obtained and each drone will be given a unique ID, similar to how we register our vehicles. And based on this unique ID and pilot license, a certification process means each US manufacturer should go through a certification process so that many of the recommendations are being followed to ensure that these recommendations are followed. So there will be a long certification process. And third one is the most important thing, like how we are having a air traffic control. ATC is there to control if any aircraft is coming into airport, which aircraft is coming, communicating with them. So that's basically it's a manual aerial vehicle traffic management. This is like a US traffic management, which is there is no pilot. So that traffic management is a highly challenging thing. And this US traffic management is going to come in India within a few years or so. So using this unique ID and all, every drone coming into the picture, it will be continuously monitored to check whether it is a legitimate or illegitimate one. If it is an illegitimate one, immediately some counter US measures can be obtained. So these are the upcoming points which are going to coming in India. So thank you. If time doesn't permit me, you can maybe questions can be sent in mail also. Thank you.
Yeah. Hello, Hare Krishna.
Sir.
Yeah, one question for you.
Sir.
If GPS spoofing happened,
Yes.
is it possible for the base station to identify it without random power consumption effect itself?
If GPS attacks come, it will be difficult for, it will depend on whether it is level of autonomy. It will depend on the level of autonomy. If it is more the control is with the pilot, it will be known to him and he can do some corrections. If it is a purely autonomous thing, means there will be no detection on the ground. It will be completely gone to that attack. So basically GPS attacks will come more into picture if it is an autonomous.
Okay, thank you, Hare Krishna. I think no more questions from the audience. So I really thank you for giving us the details on US cybersecurity threat model and security US, whatever the firmware and the hardware and all, and even the attacks on the US. Thank you very much for your session. I think we'll move to the next session. Next talk is by Mr. Vishnu Praveen. I hope he's ready. Yeah, Mr. Vishnu Praveen is a project associate at NETS. So he'll be talking on Internet Key Exchange, that is IKE for IoT. So let me speak about his profile. Mr. A. Vishnu Praveen is a part of the Hardware Security Research Group at SETS Chennai, working as a project associate. He is a postgraduate in Electronics and Communication Engineering from PSD College of Technology, Coimbatore, and MTech Research in Photonics from IIC Bangalore. And his area of interest is security in wireless communication and networks. It's over to you, Mr. Vishnu Praveen.
So hi everyone. I welcome you all for my session on Internet Key Exchange protocol for IoT. Start my. So this is my overview. So in order to better appreciate Internet Key of Exchange, we will in a brief look into what is Internet Protocol Security, IPsec, which was already introduced by Nalini in her IoT framework. Then we'll look how that is used for creating a virtual private network, followed by Internet Key Exchange for completely a computerized system. Like it's not for IoT, for an entire computer as a host. Then we'll look how that was adapted for Internet of Things. So this is a brief overview for Internet Protocol Security or IPsec. So if you are familiar with the TLS layer security, in TCP/IP, we can briefly say there's a TCP layer followed by an IP layer. So TLS takes care of security at a TCP layer, whereas IPsec is for providing security at the IP layer. And why it is called as the security suite is that it consists of a collection of frameworks. Like for packet transfer, there is a authentication header followed by ESP protocols and separate protocols for integrity check and for exchanging key variables. So what happens when you are making any transferring a packet over the internet? So first, your system will generate a packet which will be having IP header followed by the TCP data. This IP header will consist of the source and destination address, and that will go through the router through the ISP provider. It will get into the public internet, and then it will reach to the server. But now what happens is that this internet consists of all random people which we are not known, and it's an untrusted environment. Since it's an untrusted environment, there is possibility of people looking into your data. Even if there is TCP encryption inside your TCP payload, that IP information like the traffic from which source to which destination it's traveling, how often, those kind of traffic analysis it could reveal. So what happens, the solution for this is creating a virtual private network. This virtual private network could be created gateway to gateway or from host system to host system. All kind of flexibilities are available. So how this common public network is converted into virtual private network, Internet Key Exchange plays a crucial role. And that's what we are going to look today. So what happens first, there is a procedure called security authentication, where the two communicating systems will do a handshake to come up with what kind of encryption algorithm they are going to use and how they are going to authenticate the validity of originality of the data that is getting transmitted. For that, they create a logical tunnel. This is not a physical layer connection, but a logical tunnel using encryption. So they take the entire original IP packet and encrypt it using the security authentication security association which they established during handshake, and put a new header and a new IP header from this site A to site B. So even if there is someone sniffing any data, they will not know any detail about your IP or what kind of traffic you are generating. So that's how IP security layer provides security at the IP layer. Right? So one example is IP geolocation, where the IP address could be mapped with the geographical location. And suppose if you are, one example in internet is the Netflix VPN, where if you have any programs or shows which are not available in your country, you could use a VPN to mask your IP, and from the another IP from some other country, you can use it to access the same data. So with that, now I'll take you into how Internet Key Exchange Protocol works in establishing this VPN. This Internet Key Exchange Protocol is being designed by the Internet Society and the Internet Engineering Task Force, and they have the series of algorithms and protocols that they support, which we'll see subsequently. So the first step is there is going to be an initiator and a responder who will be involved in this handshake. The initiator will first make a proposal in the form of IKE-SA init, where he will share his own a random number which is called SPI, or a security parameter index. So the role of SPI here is that the IP is going to get masked. So which kind of security or which kind of encryption has to be used is going to be mapped by this security parameter index. In that, he is going to share security association proposals, where he is going to say what are the cryptographic algorithms the initiator has, and what kind of integrity check he could do, and what are the Diffie-Hellman variables that he's going to do to the responder. For example, this is a typical example where the initiator is proposing that he is having AES CBC 256 and with AES encryption with 192 as the key, again with 128 as key, and then for integrity check he could use SHA 512 or SH 384, all the suits available within. And for a Diffie-Hellman group exchange, he has group 5 and group 2. So this is a typical example how the initiator will make the first proposal handshake. And for this, the responder will pick what are the available things with him. So before we take further, we have to look into this Diffie-Hellman group, which is going to play a crucial role here. So what happens, as I said, this public internet is an untrusted environment. So the initiator and responder has to first share their secret key without inside this untrusted environment. So how they do is, first they have a private variable X. Similarly, the responder is going to pick a private variable Y, and the generator and prime number are going to be in the public. Once they pick the private number, to share the secret key, they use this mathematical operation to generate a public variable capital X and here a capital Y, and then they share this across each other. So what happens is, this is an irreversible process. Once you have taken your private variable X, made exponential with the generator and made a mod with the prime P, it's going to generate a public variable capital X, which cannot be reversed. So you cannot extract this mod X. So you can very safely exchange capital X over the untrusted environment. Similarly, the responder, he generates his Y and he is transmitting to the initiator. Now what happens? Since the initiator knows his private variable X, he is going to apply the same exponential operation on the received public variable of the responder, and again perform the mod operation, where he is going to get something like G power YX mod P. Similarly, if you see, the responder is also getting G power XY mod P. So they are using mathematics to transmit their secret key across each other. They are sharing the secret message in an untrusted environment. So this is a very fundamental and core concept of internet key exchange. How? We'll see next. So even if an attacker is able to sniff X and Y, since this is an irreversible process, he cannot get hold of small x and small y. Maybe he can brute force, but brute force he needs large computers. So it will probably take a lot of time and computation. Coming back to where we left. So first it is sending Internet Key Exchange Security Association initialization request. So in this request, it is going to share its Diffie element variable and the public key, the capital X and capital Y, which I said. So based on that, the responder will, in reply, will pick from the proposals which are the security algorithms it can support, whether it has been installed in it, and based on that, it will reply with its own security parameter index and a key. This key is the public variable and followed by nonce. So what is nonce here is, it's going to be a random number. The number which can be used once is called as nonce. This nonce adds freshness to the key. Once this two steps is completed, both initiator and responder will make something called the shared key seed. So what they will do, from the previous exchange, they have agreed upon something like PRF, pseudo random function. Excuse me. So using that pseudo random function and the initiator's nonce and the responder's nonce, followed by the Diffie element variable that they generated, the shared secret, they are going to perform a hashing function. From that, they are going to get SKey seed, which is going to be same. Once they generate SKey seed, from that, they again put it into one more loop, now with the security parameter index of the initiator and the security parameter of the responder, and they generate a string of key. This string is split into various other keys. The keys that they are going to use for encryption, for decryption, and then to check the authenticity of the message, etc. Once this is completed, using the key that they generated, they are going to now, the initiator is going to send something called authentication message, in which he is going to completely encrypt using the key, its own identity, authentication, and what are the security associations. And this is called traffic selector. So which kind of traffic server will be encrypted, which traffic will not be encrypted. So, and this will be completely encrypted. So a man in the middle will not be able to see anything. Similarly, the responder will reply, and with this 4 handshake, security association is being made. So VPN tunnel is created, a logical tunnel is built. So apart from that, this also has something called rekey mechanism. Rekey is basically is that if the session expires, they will delete the old created tunnel and rebuild a new tunnel with new parameters. And if there is any errors that's happening, they send a notification, and even to delete the previously created tunnels, they use notification. And informational packets are nothing but to check the liveliness of the tunnel, whether the tunnel is alive, even if there is no packet transfer. So they, it's some kind like they are maintaining the tunnel for a longer duration. And it also supports something called multiple child, where one host could create multiple tunnels with the responder. So during the workshop by Internet Architecture Board, titled Interconnecting Smart Objects with Internet, there was a proposal to implement a minimal version of IKE v2, which appears in the RFC 7815. So the basic idea is we have a full-fledged computer and we are constraining its resources to make it into an IoT. So to implement any protocol there, take a full protocol, constrain it, and apply it. So how the constraint happens is that Before I go there, this is the architecture for an IoT device where the end device is going to be sleepy, which means most of the time it won't be communicating. Only if there is an event like change in temperature or it has detected any movement, only at that time it will wake up. It will send message to its PAN coordinator, which will go through an edge router through public internet to the server. So to create the same VPN could be established here using the edge router and the servers. How? Exactly the same thing, but here what happens? The initiator is not provided with multiple choice. That is the constraint. This proposal is going to be static. It's going to have only one set of encryption algorithm, what are the integrity check it's going to do, and everything. And it's going to create a new norm and a defilement. So the set of parameters is going to be only one set and it's going to be static. So in order for this to happen, the responder should be implemented with full stack. It should support full IKEv2 and it has to accept this proposal and they generate the ASCII seed. Once they generate the ASCII seed, they will do the authentication method where it will show its identity and prove that it is the authentic IoT which is trying to connect to the server or the cloud. So with this, I have explained how the Internet Key Exchange version 2, which is implemented on a computer, could be also adapted for IoT kind of an environment. These are the references. Then you have to use additional features like RSA. So you have to generate your defilement variable. So you are saying one guy will share talk with A and another similarly will talk with B and establish a man in the middle. So then you have to use RSA asymmetric keys to generate hash signatures first, and through that you could overcome that. So it depends on the implementation.
Yeah, thank you, Vishnu Praveen.
Thank you, sir.
Thank you. I think we'll take up some questions from the audience, if anything are there. I don't think there are any questions from the audience. Okay, then I think let's close this session. I think thank you very much for telling us about Internet Key Exchange for IoT and how it is feasible and all. Thank you very much for that. Okay, how this constraint node it will be interoperable and all. Thank you very much for that. Okay, thank you very much. Now we have come to the last part of the webinar, that is the closing remarks. So to tell the closing remarks, I would request Dr. Sharath to tell us the closing remarks. But before that, I'll just tell his profile, read his profile so that you get a. So Dr. Sharath Chandra Babu sir is currently has joined as Executive Director SETS Chennai on 4 December 2017. Sharath sir obtained his BTech from JNTU College of Engineering Kakinada, MTech from REC Warangal, and PhD from IIT Delhi. He has a considerable experience of over 3.5 decades in R&D, project implementation and coordination, education and training. Prior to joining SETS, he worked in CDAC as the Executive Director, CDAC Bangalore, and Director of CDAC Hyderabad. He worked at Department of Electronics, Government of India, that is currently the Ministry of Electronics and Information Technology at various levels. He also contributed to telecom sector while working at R&D switching division of Indian Telephone Industries Limited, ITI Bangalore. He also worked as a faculty at REC Warangal, currently NIT Warangal. As a founder director of CDAC Hyderabad, he established the center right from the inception level and molded the center into a vibrant research, development and training center with a focus on N-system security products development, e-learning, embedded systems and ubiquitous computing. He was also responsible in initiating 6-month diploma programs at CDAC in areas of embedded systems, system software and so on. As Executive Director, CDA Bangalore, he led the teams in the area of HPC, grid, cloud computing, big data analytics, cybersecurity, IoT, ICT, and so on. He also contributed first of its kind projects such as irrigation canal automation, plant-wide networking of Ble steel plant, and so on. Dr. Sharath was also instrumental in conducting many national level conferences such as ElecTech India, Ubicom India, Parcomtech India, Think Parallel E-Suraksha, that is e-security programs. He has published around 70 papers in various national and international journals and conferences. He is a senior member IEEE, fellow IET, life member CSI, and member in ACM, ACCS. This is about Dr. Sharath. Sir, it's all over to you, sir. You can.
Thank you, Srikanth. And I think concluding remarks should not have been that lengthy introduction. Okay. Anyway, thank you for your passion to talk about me. He's actually my student, first PhD, second PhD student whom I guided. So obviously, we would like to talk more, right? So thank you all for this wonderful one-day webinar on IoT security. So I think contributions of the speakers is quite evident. I think it's the longest webinar because normally webinars are an half a day or constrained full day. But this started at 9:30 and has gone up to 5:30 plus now. I should appreciate all the participants for patiently, staying and in a hybrid mode at SETS auditorium as well as in CDAC conference halls and across the country, various parts of the country. Even the speakers participated from different parts. I once again thank our chief guest of the day today, Dr. Rfid sir, who has initiated the importance of IoT security, and also Professor Nandi of IIT Guwahati for his excellent introduction of ISCM program and keynote address by Dr. Subhashan on IIoT and security, and Mr. Mahesh Patil, whose welcome address has been an interesting thing, and Suganya for a vote of thanks in the inaugural session. And then the speakers like Dr. John Jose, Associate Professor at IIT Guwahati, initiated on security challenges in legend IoT devices. Then the drone security by Mr. Vikas Mishra, founder, president of Mylan Innovation Private Limited. IoT security standard from Suresh Chandra of STQC. Lightweight cryptography by Dr. Prem. Security framework for IoT devices by Nalini. IoT penetration testing by Dr. Srikanth. And exploitation of radio communication protocol by Mr. Amal Raj. Exploitation of radio communication protocols in Wi-Fi and Bluetooth low energy by Mr. Mijab, Ubekar, Bay, and drone as cybersecurity target and threat, Mr. Hari Prasad, and also the coordinator of the workshop from SET side. Internet key exchange for IoT, Mr. Vishnu Praveed. And all these talks were nicely organized by both the sides. Dr. Srikanth and Hari Prasad have managed, and a good number of talks, and more or less the content was quite up to date, and it was very meaningful and thoughtful talks. And I take this opportunity to thank all speakers once again, and also the people who were behind the scenes, coordinators, from the other side, Lakshmi Swari, who's saying yes for this conducting under the ISA program, along with the ISA coordinator, Mr. Chas Murthy, and also his team, Naresh and Jagadish, who were very instrumental in running the platform on that is a registration certification aspects are being done by those people, Jagadish and Naresh, and it was quite useful. ISA platform is actually cutting across because it has a length and breadth of India. All these resource centers, participating institutes, and many of the organizations who get connected to ISA is very. It also its outreach is so quite useful platform through their efforts, and I thank them all, ISA team, and also from our side, our team, Vaishnavi, Muthukumar, and team members have contributed to manage this particular hybrid mode of presentation from such side. And thanks for multiple roles of Dr. Srikanth, coordinator, comparer, speaker, and also from our side, Anita and Raja, who have in inauguration session, they have compared, and it's a wonderful experience to all of us. Thank you all, and wonderful talks by all people, and it's a very learning exercise. And I'm sure that in using ISA platform and energy and youthfulness of both organizations, CDAC and sets, we keep doing these workshops. Please keep watching. I am not sure under what banner. If you see the sets India, shortly there will be a workshop on ransomware analysis, but probably it's constrained only to the government organizations. So those who are from government, they can probably register. They can probably interact with sets and get to know that it's basically government officers training on ransomware analysis. So I just take this opportunity to tell that. Once again, thank you all for an excellent organization of this event by ISCA, under ISCA platform, CDAC and SETS for their excellent efforts. Thank you all, and thanks for the patient listening. All the best. Have a great evening. Thank you.
Thank you, sir. I think thanks for nice closing remarks, sir. I think we officially close this webinar on IoT Security 2022. Hope to meet you all in coming series of sessions. Okay. Thank you very much.
Thank you.
Thank you, sir.
Yeah, we are closing. Yes.